Okay, let's see here. Were we really in the middle of this? Should I start it over? I think I fast forwarded through significant portions of this. Oh god, my glucose level is going into the sky. Oh, all right, let's see. Did I wash my hair today? I think I did. I think I just got rained on. Big storm just came through. Here we go. Let's go to there. Let's move that over there. Close this one. Open up my YouTube channel. YouTube, other VOD. There should be a stream there. There is indeed. And it's me sitting in the dark. Pop out chat. Then I can close YouTube. Now I can turn on some lights. So let's see. That one on. That one on. That one on. And then this one I turn on. Some of these modules are really not responding very quickly. I don't know what's going on with them. I need to get a haircut. I think I need to get a haircut. God, it's so moist. Everywhere is humid, humid, humid. Oh, the track light didn't even turn on. I guess we don't need the track light today. I'm not really going to be showing anything over there unless I flip to that camera by accident. We're going to continue with the M303. I was thinking about a bunch of other projects that I could try to do. I really want to get, I want to get the schematic done. If I don't work on it, it's not going to get worked on. And other phrases that are totally meaningless in their repetition. Yeah, if I don't do this and concentrate on this and actually work on it and get it done, then it's in the air, so it'll never get done. I'm having a bad hair day. I woke up, took a shower, then took the dog for a walk during a rainstorm. So sitting here looking at my terrible hair. Let's see, what else do I need? You know what? I'm gonna turn on the track light just because it's contrast. It gives it a little lighting. Boop, there it goes. I guess I toggled it off. It wasn't not responding. It was just in a toggle state. I had it on when I started. Yeah, we got to get further into this thing, and this would be the slide control. Funny, those are inverting. So wouldn't this? It would activate one and deactivate the other. So you'd either have a capacitor on the input or a capacitor on the output. What's that going to do for you? Interesting. You wouldn't be switching like a bypass. You would be cap input or cap output. By nature. I mean, these oppose one another. And those two, huh. We'll have to see what this is doing, because this is a control leg. That's just controlling stuff. And these two actually do have connections. We got to see where they're connected. Figure out what in context of the rest of the circuit, because they're connected, but then in the actual 303 there's no other connections to this part of the circuit. It's only this. That's it. So what else are they doing with that? Because here's the oscillator, and then right behind it, behind these two caps, this part of the circuit is for slide, which makes it slide from volt to volt. From note to note. Note per volt. They're the same thing. Learn dimensional analysis. Learn it. Get to know it. It's your friend. All right, need a little bit of liquid, and I am fixing to get started early, even though, you know, I'm gonna have like 4 viewers today because we're doing this again, but maybe you guys can glean a little bit of knowledge from it, and everybody else is having a Friday, so let me just make sure my titles are okay, right? I got the right title? Did I get the right title? Yes, I did. Chill vibes. Chill vibes and streamer yelling at everybody. Am I ready to do this? No, I'm not awake. I had 1 cup of coffee. I want to have 3. I don't have any caffeine in the house, so. There is Diet Coke, but I shouldn't over-caffeinate. I should drink water or water adjacent, water with lime, and get healthy. I need to, man, I'm getting sleep tonight. I'm going to bed early. I got to bed, I don't know, I fell asleep at my desk and then woke up at 3 a.m. and went to bed. So I got to not do that tonight, because that leaves me kind of in a mess the next day. Still have a well of charisma that I can draw from, but let's not use it up. Yeah, I'm gonna take care of myself tonight and not be some shithead on a Friday. I forget which one this goes to. Probably need markings on these. Been cutting back on salt. That's always a good idea. Salads instead of chips as a snack. I had chips and a sandwich today. I cheated. No, it's not cheating. I'm really debating whether or not I want these control circuits to go up and over. I guess we'll just leave it in the way that we have it right now, but the only problem with my 3 connection rule is when you have something like a voltage divider and it gets a little weird. But I think what I can do is take this into the next part of the circuit. We'll leave a big gap there. We'll put it outside of the page, and maybe that'll clean it up a little bit. Yeah, let's get started. Fuck it. I don't have anything else to talk about. Screw this. Nothing else to talk about except this, because this is like on my mind. You can see there's still chats from yesterday up there. Things are going to be slow today, but I'm going to get work done, at least. Me and my stupid hair today. It's raining and I got rained on, so my hair obviously took the path of, well, I'm not going to see any other people today, except for the people who see me on stream, so why don't I have terrible fucking hair today? I don't need to go grocery shopping today, so I'm not going to see another human being. Except, no, out in the neighborhood I will. Maybe I'll put on a hat. For them, not for you guys. You guys get the full scraggled bother experience. Sitting there smelling like a wet dog. That's what white people smell like when we get wet. Yes, we smell like wet dog. Apparently that's a thing. I think currently dry, but it feels like my hair's wet just because it rained a lot around here and it's been like in the 90s for like a week. So everything is just hot water. It's like a sauna around here. It sucks. How's it going, Demi? How you doing? We're reverse engineering a synthesizer, essentially a modular synthesizer, but it is an m303. So the m303 is a photocopy of the TB303 synthesizer. TB303 synthesizer, very, very famous. I knew about it as a teenager, as a kid. They are like the sound of acid house, just the way that the waves are handled in the synthesizer. And I don't know much about synthesizers, but I do know how to reverse engineer a circuit. And so that's what we're doing. We are down here in the mines. We are doing the hardcore reverse engineering. I'm showing it to you guys. I'm not censoring any of it from anybody. You're not going to have me doing 5 hours of work off stream. I'm working on it here. You get to see how supremely difficult this stuff is. It's analog electronics, and it's a complicated design, and it has a lot of facets to it. This synthesizer is both a voltage-controlled oscillator, and it is a voltage-controlled filter, and it is a voltage-controlled amplifier, and it has all kinds of little features. So we're going to get into it. We're going to reverse engineer it. You guys can hang out with me. I will try to bring you guys along with my mentality and what I'm thinking about and what I'm doing. This is something that people don't do. People don't get an education on this. They don't do this. They learn it. You have to be exposed to it and learn it that way. It's just one of those things. It's like soldering, where I've had professors complain to me that all of his grad students just don't know how to solder. These kids come out of an engineering school and they know everything about doing math, but when it comes to actually building a circuit, they don't have any skills. So this is part of the inspiration of why I do what I do. So I like to show you guys all these processes. So this is reverse engineering. What we're doing is we're trying to get into the head of somebody who has built this thing and figure out why or what they're doing. Downloaded some nice, downed. I thought you said you downloaded. That's a good way to talk about eating something. Yes, I downloaded some steak and eggs. Down some steak and veggies. We're gonna get my kid is fishing. Ah, that's fun. I'm gonna cough. Oh man, the moisture is not helping with my respiratory situation. So, we're working right here. What this part of the circuit is a control voltage coming in, getting buffered, and going through what is, I guess, called slide. Actually not going through. The control voltage comes in here and it eventually goes to what will eventually be the oscillator. We need to look at that section a little bit more and figure out what's going on over here. I'm separating this out because this is the oscillator. I need to fix this $ issue. That's something I need to look up in the in sort of the fusion stuff. When you give it like a high, I think it's capital name versus lowercase name on the part, and then it won't give the dollar signs that are actually look normal. Anyway, the point is, this is going to be the oscillator. This is a voltage adding setup. Each of these resistors is a ratio of the voltage that's being added to this line. It's being pulled down by a 100 ohm resistor, and it would be pulled up if this thing was installed. So all of these voltage levels sum up together to make the note that you're playing on the synthesizer. You have a control voltage come in, it's 1 volt per octave, so any of those millivolt in-betweeners are going to be your notes in between octaves. So that comes in here and it goes out on this line. So we have a logical progression here. We have control voltage in, we have voltage out. We have slide in, and we have a bunch of switches that actually manipulate the transition between voltage levels. So these capacitors will either be added to the beginning or the end of this amplifier. So there's a unity gain amplifier. We have a voltage signal that's buffered. It comes in here through the 120 kilo ohm resistor, and it either gets a capacitor to ground initially or at the outset. I don't know why. That's kind of a neat thing, but slide whistle, yeah. Beep. We've been getting into it. There's a little bit more to the slide input. There's a diode on there that we need to get to the end of the path there. We have a voltage divider that goes into a transistor that has a pull-up in order to keep this high Z input from, basically, when you turn off the transistor, that resistor makes sure that your voltage level goes to the high voltage level. So then that becomes a low out of the front of this thing because it's inverting. So there's a low here, which means that this switch here is not triggered. But if there's a low here, that would mean that there's a high here because this one is also inverting. So that gets inverted and then this gets switched. So without anything going into slide in, this defaults to 12 volts because nothing is triggering the ground here is connected, it goes to ground, right? So that means that these capacitors are on the output of the buffer amp. When you do trigger slide in and you give it a voltage, then this will bias, this will pull this to a down logic level. So this will be low on the outset. No, wait, it'll be high. And then that triggers this one and untriggers this one. And so these capacitors will then be on this side of the op amp. Kind of cool. We got to see what else is going on here though, because I mean, there's more inverting gates and there's more switches to be explored. I don't know what else is going on over here or what it could be possibly doing, but having this stuff over here, we can now see, you know, the logical progression that everything is sort of being, I don't know, it's just the way it is. It is the way it is. Anyway, let me get this up here so the pull-ups are all above the pull-downs, because we clearly have a summing section, although actually fitting this up above is probably not going to be all that easy to do, so I'll just put it up here like this. Unless I move everybody down, which I could do, but we're not quite done with this section yet. So I'll put that here for now just as a placeholder. And now, like I said, I do everything in my power to avoid four-way junctions. That alleviates confusion. If something isn't quite drawn correctly, or if you know, you have a, what the fuck? Or if you have a signal going over another signal. Why do you do this? Control Z. Jeez, I guess I'll just grab them one by one and move them. We'll just put this all the way out to the edge. Yeah, it's like when it crosses over, it does weird stuff. I don't know why it's not so flexible with the lines. We can pull this out a little bit, give it some breathing room. We'll put that all the way down there. Space this up a little bit. Just give everybody a little bit of air. Okay, that's not what I meant. That's not all going to move together. Darn it. I need the lasso tool to do that properly. Okay, so I mean that's a little sloppy. Everything is a little bit too huge, but it does give us room to work. Now, let me move this over just a little bit more. Take you all the way over to there. What the heck? Weird. Just weird. Anyway, yeah, CAD is always a little bit clunky with stuff like that. Okay, so getting into the oscillator next. First, we need to get into these other two switches and this diode here. So where were we? Well, we were working here, and we're somewhere around here. We need to mark down what we've already done, too, because I don't know if I got that the switch control pins. No, I didn't. Okay, so let's mark that down. So now we know. We've come to an impasse. We know that we've done these two pins here. This one, and I'm on the done layer. Okay, this one and this one. Oh, no, sorry, this one and this one. And so this goes up and over, and it goes to here. And then we got this, and this one, and this one. And we know, let's see, where's that one going? Oh, that goes over there, and then this one goes like this. And we got this transistor here, because this is the input from the slide whistle. We got that, we got this thing, we got that one, we got this one, and we got this, but we didn't go beyond that. This, up and over, all the way to slide whistle input, which is this pin right here, which we got. All right, we're making progress, we're making progress, we're making progress, we're making progress. Gotta keep reassuring yourself that, you know, we're making progress. So that's positive V. Put a plus right there just so I can tell myself that later. What else? What else did we do? We got the output from there. I got this connection here, which goes back to yeah, that goes to this switch. Okay, cool. The ouch. I hope I'm not derailing your stream by asking this. No, you are. But that's fine. Ignore me if I am. No, I refuse. I refuse. All right, anyway. Back to this. Let's see. No, just kidding. Being ADHD and streaming. Name a better combo. Okay, what are you asking here? Would you happen to have any recommendations on places to find a library of Raspberry Pi projects? Either hardware, software, or just software? No, I don't do a lot of stuff with the Raspberry Pi. You gotta understand, the Raspberry Pi is too big for its own good. It's too much. Like when I do a project, because I have a degree in engineering. I've done a lot of this stuff. I've done embedded stuff like since I was a squirt. Not really. The basic stamp was popular when I was a kid and then moved up from that. But nowadays, like every single microcontroller is so powerful. I was forged at a time when you would very carefully choose your requirements for a microcontroller, and then you would code within those means. And so you'd always be trying to minimize your project into its component parts. Nowadays, everything can do everything, and it can do it with just complete wanton disregard for specs like we're running like hundreds of megahertz on these microcontrollers now. Everything can handle everything with gusto. So why would you have an entire Raspberry Pi doing the job of something that a Teensy 4 could do? That's sort of been the Raspberry Pi was really cool because you got an entire computer for $20. That's not the case anymore. You know, they've lost that somewhere along the way. Now the Pico Pi is the RP2040 is an extremely powerful microcontroller that can do a lot of cool stuff too. But I think in those terms, I don't think in terms of, well, I could write a Python program for this. I'm like, I could write a MicroPython program for this instead, and I could make it small. And like that's starting to die. That kind of sentiment is starting to die. Like it's starting to become, I can put the most powerful computer ever on to blink this light bulb. And by the way, not to take anything, you know, a lot of people like to say that. They say, oh, you're just blinking a light bulb. Well, it's not just blinking a light bulb. It's learning how to make a light bulb blink within a system. So when people say like, oh, you're just using a Raspberry or using an entire Arduino to blink a light bulb, just use a 555. It's like, bitch, I don't want to do equations and use some antiquated fucking 555. Like, get with the times. Put on a pair of sunglasses and start reading about how to do things, because you've clearly fallen behind. Nowadays, doing like an embedded systems project that seems too simplistic for the platform is a thing that you should do. I've just been trained in the opposite, because it's like you shouldn't, but that's not true anymore. It's like you do the simple thing on the badass platform, because next time you have a much more complicated project, you've already forged the pathways into making that happen. It's a weird thing. Like, it's hard to reconcile. looking for ideas that'll get me started, but not bore me to death. Like I can make it like turn it on off. I don't know. I don't know any Raspberry Pi specific project sites. I have to stay away from project sites because I just keep finding projects. That's the problems. Oh, that'd be cool. I should do one of those. No. So it's like every time I go on Hackaday, I'll find pieces of projects that I want to do. It's not good. It looks like these two have been blanked out. It looks like these are not used. Let's double check that. At least this one I think is left hanging over here. Well, then the other question is, are there traces that I didn't? No, there aren't. I think we got everything on this one. So what is this right here? This one goes off into parts of this circuit. So that's doing something. Power and ground are on opposite ends here. And this one is going to ground, actually? That's interesting. I guess it can handle 12 volts. It can't handle 24. Yeah, I hope you can find something good out there. It's like, your Hackadays and stuff like that. But good luck. I know nothing about it. These are fixed and going to ground. That's the weird part. What up, Madam? Did you show up on? Yes, you did. Good. Everything is working. It's strange. Things actually are working. Okay, let me think here. We're trying to get to the bottom of this diode, and we're going to move out from here. I'm marking down what we've already done so that I don't get confused and so that I can come back and actually lay out this whole thing appropriately. Okay. All right. I think I have everything marked down. So let's get to the nitty-gritty down here. I'm going to try to enunciate and let you guys know what I'm thinking, what I'm doing, but I'm here to get work done, so I'm going to do the work. 2202. So that's 22 kiloohms, 22000. So we got a 22 kilo ohm over here. Now let's go back to our parts, and let's find a resistor. And we've got 0805 is still selected, mercifully. Right click, value, 22K. And I use that because the R's and the D's and the C's and the B's aren't useful to us because nothing is labeled on this board. What up, Lexi Timey? 22K into, what is this? Another 22K, another diode, and a pin. Where does this pin go? Where are pin? Gate in. Aha! Interesting. Gate in comes in, and it goes to this juncture here with 22K. Well, let's go ahead and copy this one. Copy that floppy. Put that over here. And I'll copy the text even. Call that gates. There's our gate in. All right. Now that automatically goes to ground on this pin. They don't mess around with that. So we'll grab this, copy, put that down here. Yes. Okay, now let's check to see whether if you don't put a gate in, if it goes to ground. We need to actually look at the physical thing here because I didn't mark that down. So that one is coming in on... Actually, we can just look at the plug. Where's gate in? Gate input. It's below VCF in. There, we're too close. We're too much of a close talker. So the way that I can tell what side of the board is what, because this thing is so fucking symmetrical, is that we have a knob and a plug, or a plug and a plug. So we have a plug and a plug in the upper left. That's like this. No, that's like this. This is right side up. This is upside down, but this is right side up. And so gate in is right here. So gate in on this one, what happens when it is unplugged? Well, since we know the pinouts of these things, it looks like gate in, the switched one goes to this pin down here. And then the actual gate in goes to that lower corner. So one goes to the lower corner, the other one goes right next to it to cut it off. What does that look like? So in this, we have our gate in. That ain't how it works. Wait a minute. Wait a minute. Gate in going to these two, but when I look over here, man, I was why are these circuits always gaslighting my ass? All right, so we've got CV in, VCO, CV, VCF in, gate in. Gate in is right above the header. The unswitched, oh, they are next to each other. But these are showing them on, yeah, because they're flipped 180 degrees. And they are right next to each other. It's the one in the top corner, because it's like this. So it's that one and the one right next to it. Okay, so that is the way it is. I don't, like when Speedy Cat said, I mostly do through hole. I'm like, how? How do you do that? Because like, I am so confused with this crap. This thing barely has through hole devices in it, and it's already completely mystifying me. Yeah, I started right away. I decided not to do an intro because I was too interested in this stuff. Which one is the switched pin? Double check my work here. Am I on the wrong side? Yeah, here it is. That one is coming from the switched one. No, the switched one is on the corner. So that means that the one that goes to the diode is the one that cuts off when you plug in a gate signal? That doesn't make any sense. Oh, wait a minute. I'm going to double check. The one that goes to the corner, and then the one that is not switched. Okay, yeah, no, the corner is the one that's not switched. The corner is the output from the actual, okay. So the one that takes the signal away goes to the diode, and we'll just copy this stuff. Copy that floppy, pop that shit right there. Oh, no, not you two together, just one, like that. And then something's going on with the unswitched one. We have other stuff going on. So let's take a look at what are have do when this is not plugged in. We go up, over, around, down, through, back, in. What are do now? Wait a minute. Oh, down, over, under, through, and to our gate signal. So that goes to the front panel. How are we denoting that before? I think I just did a line with the signal on it, because that was in the power supply, or no, that was in this section. Yeah, it just says CV, so this one is going to say gate. So that's the gate input from the from another area, from like another synthesizer. It's plug on the back. So we'll just do name and then gate. Connect it, name it, shame it. There we go. So they're doing the same thing with this one that they did with the CV input, is that if you have a signal plugged into the back panel, it travels all the way to the front panel and then goes into the circuit where it normally would go, unless you plug in a gate signal. So I guess a gate signal is kind of vital to this thing functioning. But we got another 22 kilo ohm, and then these two meet up. These two are like, hey, what's up, man? How's it going? So why then? Why would our slide in and our gate in co-reside on this signal path? Interesting. Slide and gate in. All right, let's see here. So we're still at the mystery of the other side of the diode. We are here. Two of those, and then we get a 1002, so it's 10K, going to ground on an NPN transistor. And the common is connected to some shit. No, that shouldn't be. How can that be? That shouldn't be. Look at the bottom layer here. That is our waveform. What the fuck? Goes up and around. Oh, it doesn't connect there. Oh, I see. Okay, okay. I am confused. Okay, so what we're getting into the rest of the circuit over here. That's this stuff. Not this. This signal is just traveling through on its way to the filter. So we ignore it. We ignore it. It's not there. 10K to ground. Ah! Okay, grab this. And we need a transistor, and this one is just a standalone transistor. This one is part of a group. Where's our other standalone? There's our other standalone. So I'm going to copy this one. Place that down here. Now, does it go into the base? Is it based or not? It does go into the base. That's got down, and that's got down. Okay, cool. So that means that we are a traditional transistor sort of layout. Copy this. Which makes sense for a gate signal. And I'll probably want to move it down to give us a little bit of space to breathe. Yay for more fusion content. Not all share your particular love of the fusion. That's fun enough. At least it looks nice and organized. And the what is it? The ad people love it. Like, hey, we saw you were using Fusion. We're wondering if you wanted a license. You got a license. Yeah, I got a license. How's it going, everybody? We're just hanging out. We're doing circuit stuff. So things will be what they are. And we're just going to chill out, and we're going to put together all of this complexity. And as we go, we can learn a little bit about how the synthesizer functions. So far, we've learned quite a bit. My eyes are open to how this thing works. Also, I'm running out of space right here. I got to move us away. Nope. I wonder how I deselect with that tool. Can I control and then add more? No, I can't. I can specifically click on things. Ah, damn it. All right, let's move you down. Like that. It seems like, I mean, the diodes seem to be there to isolate the signals coming in, the control voltages coming in, and it seems like we are splitting it between slide in and gate. So I guess slide in will gate your signal in a weird way. I don't understand that, but that appears to be what's going on. All right, so we've got a 22 kilo ohm going down to ground, and that's just making sure that this thing biases downward, I guess. Let's just make sure that that goes to ground. It seems like it should go high, but I guess... Oh, I see. So slide in turns off gate? Huh. I don't know. That doesn't make much sense. Both of those are in the same direction with a 22 kilo ohm, and they come from directly from outward signals, this one and this one. And then this has a... It does have a 10K to ground. There's no getting around that. And let's see. And then that goes to ground as well. And our... collector goes off to a bunch of stuff. What happened there? Wait a minute. Collector with a capacitor to ground goes to the input to another Schottky. Another Schmid, rather. 14, 13, 12, 11, 10, 9, 8. So we want pin 9 to go to this collector. Pin 9. Pin 9 over here. Oops. Nope, nope. There. Pin 9 goes to the collector, but then it also does some other stuff. And there's also a capacitor in there. So do we have just like a ceramic? Let's just grab one of these. Let's copy this one, and let's put that over here. And I'll also grab a ground. Copy that, bring it all down here. So there's other stuff that it does, but right now we can see that it does do this. Actually, I'm going to go like this. And then, oh yeah, connect that to ground. Oops. A little weird. So nothing, oh, I'm going to guess that that other branch of this holds it high. Let's check. That's not what I'm looking at. We're looking at this. Boink. I'm going to guess that we are going to hit, yep, there it is, 4702, and there's another capacitor and another transistor involved in this too. We're going to need more space, but at least right now what I can do is I can pop a 4.7, sorry, 47K, 47000, 4702. 47K onto this that goes to plus 12. Copy. Place. And we're going to need more room. Value 47K. I don't know why 47 specifically. That seems like an odd one when all you need in that spot is just a pull-up that is significant value so that it doesn't ruin the rest of your circuit. The annoying part is going to be getting that text back up. Well, we have to rearrange it anyway. Right, R22, 47K. And I need a plus 12. I'll read the comment in just a second. Copy. Paste. So yeah, the capacitor charges up, and when this thing finally gets to be gets biased, it'll pull down, and then that'll activate this over here. So this thing goes positive when this gets biased and pulls this negative. We've got a lot of like flipping going on here. What percentage you'd say we've progressed towards fully replicating the board in Fusion? Very, very little. Very, very little. This is see the amount of yellow on everything. The amount I've pissed on this board. How much would you say I've pissed on when it needs to be 100% piss? So yeah, we're working. It's not worth thinking about percentages right now. Why are you being my manager? I don't recall you people being posted as my fucking manager. Jesus, coming over here. How much would you say you've done so far? I'll get those reports in. God, you fucking people sicken me. I piss on you. No, anyway, I'm just being hyperbolic. All right, we got a capacitor here that goes over to a 10K that goes to another transistor. This one is a P channel. Speaking of P, I need to report it to the C-suite. Yeah, it's a fucking question. God damn. Okay, so let's see. It'll get done when it's done, and that's the way we like it. Let's see. Capacitor to ground we got. The gate we got. What are happening here? Wow, there's a lot of stuff going on over here on the other side of this thing. Listen, I've been around the internet more than twice. Yes, I do know this. Capacitor to 10K to the base of a P-channel FET. Let's get that in there, and then we can look at what else is connected to pin 8 over there. So we need to build this out a little bit, unless we go up with it. And I'm not sure if we go up or down with it. I don't know what direction we're taking this in. So let's go ahead and look up a part. I know we have it. We made it yesterday. Bonk, and then we go to, not the MOSFET, we go to transistor P channel, and we drop that mofo down here. We don't know what exactly is going on with it yet, but we do know that we have a 10K. And wait, with blah blah blah. Burp, burp, burp. Okay, it goes through. What a clunky trace layout. Clunky trace layout. That's a little weird. Why would you do it like this? That's strange. Okay, anyway. I mean, they were going for like an even distribution of devices. It's just weird that you would come up off of the pad and what was going on there? Up off the pad at a weird angle, and then here you're coming down, like straight down. When you want to just like, I don't know. Anyway, all right, fine, whatever. These are the little like micro decisions that you make while doing stuff like this. And sometimes they're good decisions, sometimes they're bad. And then we're going through a resistor, 10K. Value. And oh boy, we're out of space over here, huh? I guess I'll just pull all this off of the page. It's going to start interconnecting with stuff up here too, so we'll have to just pay attention to that. That or I just get rid of the frame. Maybe I get rid of the frame. I like the frame. It helps me kind of like keep my thoughts organized, but it might be working against us. Whoops, okay, well, I'll just leave it alone then. I watched for the 20-year-old Aqua Teen Hunger Force references. It was a good show. All right, let's see here. Bring this down to there, bring this over to here, and then, oh, that shouldn't be so close. I can get a little closer. Okay, that's our P-chan. We could probably drag all this stuff down a little bit and just, you know, meet up right here. That's a general organization thing. Polygon selection. This is where we get crazy with the polygons. Wait, I thought it just chose polygon. Oh, here we go, yeah. Well, that didn't help at all. Why is this not... I move you, and therefore you move. What is going on here? Here, you get out of here, place component. I'm just going to delete my way into reauthoring the whole area. Oh, I'm still in polygon selection mode. God, that selection mode is annoying. Because when you're in polygon selection mode, when you click, it's like, oh, where are you going to make your polygons? And you're like, wait, no, I'm just trying to click on something. There. I don't know what the rest of this is going to look like yet, but it's there for posterity, just so we know that stuff is happening on this trace. Let's go for the P channel now. Like, this is confusing to me at this point, but we're getting there. You don't use the CA3046 for the 303 VCO. There's no need for it. The 303 VCO is more like a voltage comparator. No need for matched transistors. I don't think so. I think you're completely wrong about that. Maybe you're not, and you just understand this stuff better than I do. But like the matched transistor pair is very important for making the oscillations right here and making them consistent from product to product. In addition to that, you need the matched transistor pair so that your filter is also consistent on its supply and its drain lines. And then what they're doing, what Acid Labs specifically did, is they used a special transistor in order to get, I guess, more matching pairs. It doesn't matter if the different rungs of the ladder are different. It's the ones across from each other that should be similar. I don't know why. There's a lot of stuff I don't know about this filter. But from what I understand, you need to have a supermatched transistor pair in order to have an oscillator like this. That's what I understand anyway. Your opinion is controversial. But they use that 3046 because you could buy 5 at a time. You get all these matched transistor pairs. It's great. Should I drop down before having these two connect to one another? I think I probably should have dropped it down a little bit further. Oh well. I had to make it like this because you can't have 2 pins that are the same pin within a single device. I don't know why that is. Maybe I could figure out a way to get around it, but when I was putting this thing together, I couldn't come up with a way to get 2 pins in the drawing to represent 1 pad. Maybe I could have edited the pin and had the 2 pins referencing. Maybe we got to go back into this device and fix that. That might be the way to do it. Anyway, back over here. We're still working on this. We don't know nothing about nothing. We got pin 8, we got pin 2 and pin 3, but we don't know where they're going. So let's take a look at what U2. Why is that U? That should be Q. Oh, weird. That switched its identity. This one is Q2. This one became U2. Q, U, Q. Oh, it's because the PNP, because what we did in the PNP. I'll have to revisit that and figure that one out. Okay, so U2 is a PNP. What is the PNP in bonk? We have, oh boy, where is that going? That's positive power, comes in and goes both to the emitter and the base through a 10K and a 22 ohm resistor. 22R0, that's interesting. Well, it's a limitation of fusion. Having more pins on your drawing than your pads, it doesn't allow you to do that. You can't select a pad that has too few pins. You can have more because you can have multiple pads for 1 pin, but multiple pins for 1 pad, I think what I need to do is go in and edit the pin and tell it that it's the same pin as the other pin. I think that's what I need to do. We'll try that in a minute, but it's a software limitation within Fusion. But yeah, okay, over here we've got our pin P, and so our pin P also has some pull-ups and stuff, and then it's the collector that goes out to some other stuff. It's also got another pull-down on it. So we can see right here, I mean, the capacitor going through here, killing the DC, we're coming through here through 10K, and then we have pull-downs on both the base and on the emitter. So the pull-down on the base is gonna make sure that it's flowing unless it gets current. Oh no, but that's going up to positive, so 10K to positive. So let's take a vertical 10K. Take that over there, and that goes to value, and that one's 10K. And we immediately need more room, so this needs to drop down. Bring that down there. Let's make this even on the line, and let's pull this down over to here. And then that 10K, oh wait, no, 10K is on the base. So we'll spread these out a little bit, make a little bit of room for my 10K right there. And then I need positive, so I'm gonna go over here and copy. That didn't come with a voltage. What's going on here? Is there a 12 hanging out somewhere? I don't see any orphaned 12s. Why would this not have a 12 on it? I'm gonna delete it and make a new one. There we go. Huh, I don't know why it didn't carry a value with it. Weird. All right, copy it again. Bring it down over here, put it right there. So analog and logic. It's fun to look at how these different signals are being interpreted by logic elements, on and off elements. Yeah, that's exactly what I'm thinking. That's pin description. So 10K, and then copy this over to here, and then this one becomes a 22 ohm. That's a very low value for this thing. Value 22, just 22. I haven't been using the ohm symbol. I don't have a keypad on this keyboard, so I can't do the Alt key. Used to have it memorized. I used to, micro, and then also, what do you call it? Micro and ohms. I used to have memorized. Never used Fusion to do schematics. I've only used KI CAD or OrCAD. I forget what the one I used was. I forget what the name of it was. It was some other type of CAD where it was like, as you thought about what you're doing, you're like, grab component was the letter G and then the letter C. So you could really fly through a schematic if you got good at it. And I did. And I did. Is this what I have? Oh, I didn't notice your chat, Andrew. Is this what I have to look forward to when I reach my junior and senior years of my computer engineering degree? I don't think so. I mean, you're not going to be making a synthesizer, first of all. Ha ha ha, you should be so lucky. I don't know. I don't know if this is what you have to look for. If you get a degree in electronics, maybe, but this isn't that. I really need to get this frame letter out of here. Let's just delete that. There we go. Okay. Now we can join the rest of the circuit now. I know we have to deal with the existential dread of the void, but you know, we can reconcile the existential dread and power through. No Temcos. I haven't found a Temco yet. I don't know if there's a Temco on this design. The synthesizer builders love their little Temcos, because then you temperature compensate your supermatch transistor pair. That might be what R100 is in this one, because it's got this little hood around it. I'm not sure. This one is the m303, which our design is based off of. We don't have a schematic for our design. So we are reverse engineering the m303. And so that's what this is. So this is going to take on a slightly different form than our buddy over there. Here, let's get this a little bit organized. We can get, I was filling the page, because a lot of the time I'm making schematics specifically in order to be published on a page, and we don't have that restriction on this. Now that I've gotten rid of the frame letter, we're free. So I can just make this sort of look the way I want it to, and it can be compact. Moving these elements around until I feel inner peace. This does not spark joy. Boy, they really make it hard to flip apart in this program. Unfortunately, my voltage dividers look a little awkward in Fusion just because of my rule of no four-way junctions. That's on me, but I'll learn to live with myself. Cool, that's exactly what I wanted to have happen. Let's just leave it alone. This would be more EE, although CE is a subset. Yeah, and the thing is, like, reverse engineering, you're not necessarily going to find yourself reverse engineering stuff out of the bat out of academia. Your boss is going to come over and be like, we need you to copy this product. It's like, hello, ethics. All right, yeah, U2. Let's get back to it. U2. Oh my God, look at the size of that thing. It's big and round and bulbous and plump. That is a 447 microfarad, 48 volt, no, 25 volt, whatever. Big cap, big capacitor. And that is our connection to ground from the emitter. Where else does the emitter go? It doesn't go anywhere. Emitter to ground. Wait a second. But that positive comes in and it goes here. These pull-ups. Oh, pull up and then pull down to ground on the emitter. So yeah, okay, so that gets a big cap. So we need to move this out just a little bit. There we go. And then, oh no, that's down here. No, that's not, no, you're fucking crazy. Move this out, and then we put a big polar cap on this thing. Big polar caps I have on the other sheet, so I guess I'll have to add one from the parts thing. So I go to the parts thing here, and I go to capacitor. We're still in components. Cap polar. Or polar cap, cap pole. Size G. Is G the big one? Hard to tell. Yeah, G is like monstrous, but it doesn't have a 3D model. I did a bunch of the sizes of 3D models, and I spent a lot of time putting them together. I don't know why none of them are here. I'm a little worried about that. I think I lost a lot of work somewhere. We'll make it a size D. I think that's the fairly chunkiest one. Size D cap, and we'll just put it here because we're going to have a crossover line. We try to avoid lines crossing over lines because that's a huge source of confusion when reading a schematic. Copy that and put that down here, and I should know because I've seen my share where you're like, wait, is that connected there or not? And this is the reason why I don't do four-way junctions, because if you have a four-way junction and you forget to put a dot on it, this looks a whole hell of a lot like this. And so if you never do four-way junctions, if that's your, like one of your founding principles of schematic design is that I never do four-way junctions. I don't go down on four-way junctions. If you have that attitude, that means that the mistake of not putting a dot there doesn't exist. These simply do not connect. That's why I don't do four ways. Bonk. Use Express PCB for my designs. Print on overhead sheet, UV develop, etc. drill. I used PCB 123 for a little bit, and Express PCB is where I cut my teeth. But I never did my own boards. And nowadays, since they're only $5, it's like, pfft. XPCB? Oh, Express PCB. Yeah. Express PCB was okay. It was like one of the first ones where you were, the consumer got the free program and was able to do the kind of design that the professional programs do. So we have an RC that we're pulling down. I almost want to put the RC up here. I think that's what I should do. I think I should take this and actually have it go into an RC junction that's up above, just because that displays to me what's going on. This is going to be a very busy schematic when it's done. Okay, let's bring this down a little bit. Like that. And then give this over here. Bring this here, I guess. That's still pretty clunky. I don't know if I totally like that. Takes up a lot of space. For now, we're going to do that because we are hopefully stressing readability on this one. We're stressing readability because this is supposed to be a schematic that we read and understand and know what everything is doing in. I mean, I could also lay that flat and just have positive and negative on either side, and then it would communicate everything that it's doing. Maybe we should do that. We're going to lay this one flat down. Oh yeah, value 47 F. Capital F. UG. I guess 47U. I'll just leave it like that. It'll be fine. And yeah, I'm gonna lay this flat. It's way too tall as it is, so. Like that, and then we'll put C9 up above and 47U down below. With alt spacing. You have a couple grids that you manage in Fusion, and yeah, one of them snaps, the other one, well, one of them gets you in the ballpark, but then if stuff runs into each other, you want to separate out the elements. Okay, and then this one like this, and that way everybody fits. And this, doot, 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 and doot, 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 good enough. Boop, to boop, to boop, to boop. And then pack it in. For the specific purpose of having this take up as little room as possible. So now we can kind of see an RC there. Let me just make sure that's all there is to it. Imagine a fart box fart. No! Rotate a cow in your head. Now we can move that up a little bit. There's a lot of like minor rearranging that goes on in this kind of thing. you like move stuff, you move it again, you move it again, you rearrange large stuff. It's all just a big hassle. But eventually, hopefully, you get a readable schematic. What this means is that when this is not activating, well, I actually don't know what's going on the other side of this, but through this very small resistor, this is taken up to 12 volts. This capacitor is charged, which means that it becomes an open circuit. So it's a closed circuit until it charges. And at 47 microfarads, that is a big capacitor. It takes a little bit to charge. It's like microseconds, but it still takes a little bit to charge. So once that thing charges up, that is an open circuit. And so sitting on the I guess the emitter of this FET, it wants to flow current all the way down to the collector, right? To pin 3. Well, actually, that depends on what things look like on the outset. We need to see what else the circuit is doing. But whenever this activates, this current would bleed through this and discharge eventually with this thing supplementing. Why would... It's polar capacitor, so it would just discharge, and then this would become low until it deactivates, and then this 22 ohm would charge this up very quickly. I gotta check out what this thing is doing. We gotta look at more of this part of the circuit. I have a feeling there's more to it than that. Well, no, there's not. It's just the pull up here, the resistor, the emitter, and then the capacitor. Huh. Arrow going in. Yeah, that's what we got. All right, well, what's happening on the collector? On the collector, we have a... What is that value? Oh, where did my tool palette go? I guess that was the button that I was hitting. Hey, layer view. Oh, did I hit like F11 or something? No. Nope. I'm hitting random stuff. These are like tools. Oh, tab. Oh, that's a cool little thing. I should remember how to do that. Hitting tab in GIMP brings you to full picture mode. Okay, cool. So, all right, let's get the top layer out of here so I can read what that resistor is. That is a 102, or no, sorry, 2202, which is 22000. Oh, you were just a little bit too late. I figured it out just before you said that. Curse you, delay. It makes delay works to my advantage. It makes me look smart. Nice to have. 22K to ground. Where's a nice vertical 22K? Well, that's actually 22K to ground. That's exactly what I need. It's everything that I need. 22, and then let's bring ground in here. And that'll go right here. Geez, getting out of the tool is important too. That's a big value. So whatever's on that line will be discharged to ground through that, but it's a 10 times, 1,000 times larger than the R25. Interesting. Very interesting. Is this PNP the right way around? Hold on. I'll look up just like a PNP transistor circuit. Smooth brain smoking. That's a good combo. PNP transistor circuit. Just get some inspiration of how people are building their PNP is what they look like. So yeah, you have your load down below, and then you have the arrow coming from up above, and generally, well, this one has the arrow coming in up and in from below. That's not PNP transistor circuit. This one is a PNP transistor circuit. What are they doing over here? Why is this? They're just trying to quiz you on weird stuff. That one comes in from below. This one comes in from above. I guess well, see, then this one again comes in from below, but that's positive. Oh, they flip the battery around. Yeah, all right. All right. So I have it the right way. And generally, I mean, what I could also do is, in order to communicate that this is coming from here, I could make this vertical, and then C9 can come off of this as sort of a horizontal jaunt. This is going to connect a bunch of stuff. No! Man, Fusion is not good at this. Just do it like this, and then it sort of looks like it's discharging that. That takes up a shitload of vertical space, though. Well, I guess we have it. We have it in this area, so I might as well use it. What in the hell? It's all over the place. I'm doing this for readability, and I'm not really sure what the result's going to be, so I'm just playing with the structures and seeing what looks best. I gotta make room for the ground signal in there. And you know what? That's kind of hideous. Let's Control-Z our way out of that one. I don't like that structure. It just doesn't look like it's pulling up from my mind. But if I make this vertical and this vertical, it takes up way too much space. So I guess I'll live with it for now, but I don't like it. I would rather, because I like to see stuff, you know, going up and going down. Like it's just what I'm used to seeing. All right, anyway. Okay, where is that emitter, or collector rather, going? Collector going over here goes to, that's that we just put in, and then we have two diodes that go two totally separate. Oh my god, it keeps going. It just keeps going and going. Okay, so that's a ground, so we can ignore everything over here, but we do have two more diodes, two more small signal diodes. So copy that floppy and bring it all the way over here, and we'll put D and another D. And let's branch it out. We'll move it over if we need to, but for now we'll just do this. Jesus. What is flowing? It's flowing this way, so when this switches, this goes positive. When it unswitches, it'll instantly go unpositive, but then it'll charge up again. Or this, no, but that'll take it over. That ground will be overwhelmed by all of the positive current that comes through here. I don't see C9 discharging, but it's this huge fuck-off capacitor that they have in there. Weird. Maybe that gives it like a little heel or something like that. It just softens the blow just a little bit. And we keep branching out into these circuits and not resolving like these hanging little functionality chains, which is a strange thing. I don't know when we're going to run back into it. Keep moving, though. We keep moving. Let's mark off the stuff that we've done so far. So I go to my pencil tool, and I go to my piss color, and I go to the done layer, and I make the pencil nice and big, because I'm just basically running my highlighter over everything. So highlight that, we got that, we got that. We got this connection here, we got this PNP, we got this resistor here, we got these two mumbo jumbos going over to this thing where it's actually positive power. We got this one going to positive power, we got this right here and this over here. This one going to positive power on the collector of the NPN that's over here. Yeah, we do have that, okay. 4.7, we got the junction here, we got this thingamajig, this little diode here, and we go up to there, and we, wait, hold on, which one is it? It's this one, so we got that, and then we got this guy right here, and then we got this connection here, we got this here with the diode coming in, we got this one with the diode coming in, we got this one here, then we got this one, and then we can do this, and then this one, we can go all the way back, straight up here, traveling all the way till it gets to the corner. And then we got its body from the corner. And we go up and over and around. Jesus, this thing is traveling quite a distance. I don't think... we actually might not have gotten this one yet. Oh, yeah, we did. Yeah. All the way back to the front panel. It goes down and over. I've done a lot of circuit boards where I've had to do this. You have to walk all the way around the park in order to get to where you need to go. It's something that you do in the later stages of design, because you put down all of your complicated circuit structures, the stuff that's going to be hard to lay out, and then you have your travel lines that go all the way around the board in order to get to where they need to go. That's just part of a circuit board coming together. So we were here, and we've just gotten into these two diodes here. So we've got, oh God, where is this going? We go back and we go to another switched structure, huh? Yikes. Okay, so, unless that's a voltage line, I don't know. This is 0 ohm. Jesus. Okay. Continue moving on. Oh yeah, we got this one too. Donk. Donk. Donk, donk. There we go. Cool. We haven't even gotten into the filter section yet. Like, this stuff just keeps going, doesn't it? It just keeps going. All right, so 22 into an NPN. 22K into an NPN after this diode. It could be either of these. And both of the diodes go to resistors, so let's just do that. And set the value here. Well, the 22 goes into a transistor. I wonder where the other one goes. If it travels somewhere else, we'll find out. We'll do it just, yeah, value. So we'll do, this one is 22K. And we'll trace the 22K first. We'll just leave this one kind of hanging out. Let me delete this resistor. So we'll start here and just figure out what the circuit looks like, and then we'll get into the other one. This is going to get crazy, and it'll get complicated because it's going to start relating to the stuff up above. Oh, we don't need place. See, I have to maximize the amount of space here, and I need to work big. I'm used to working small because it's just me, but I have to remember that you guys are here, and I need to bring you guys along with me on this journey of circuits. Join me on a journey of circuits. A circus of circuits. All right, back to the design. So, 22 kilo ohms right there. There it is. Look at them. 22 kilo ohms. If I ever see that myself. Get back out of here. 22K into a capacitor to ground, and then on the emitter of an NPN. So the base has 22K and a cap to ground, both. Already we need way more room than this. So you are going way down here with the fishes. And then this goes into an NPN. So we find an NPN and we copy it. Okay, and then this goes right up near the diode. This comes up over here, and then we get a capacitor to ground. We don't know the value, these little ceramic ones. I mean, I could test them. I could probably get in the ballpark if I test it, but it doesn't matter that much. None of them are like unique values. They're probably all somewhat within the ballpark of one another. Unless they're the special ones, like the ones that are used all the way up here in order to do whatever this skibbity toilet shit is, a slide. Yeah. I may want to pull this to the left a little bit, just so that I can have these two lines go up and over. Although that, I mean, that does communicate it pretty well. I don't know, maybe it'll be fine. I guess I could move the width adjustment over to the right, and then I can move this, so yeah, I'll do that in a minute. First, let's just get this down. Okay, and then I'll travel over here and just do the edit that I was just thinking of. Well, width and frequency I can have on top of each other. That's just natural. And then this now has a little bit of space to breathe. So, I didn't click on that. Why did that take so long? This is weird. I hate it when you do something on the computer and it's like, hold on, I got to think about that for a half an hour. Even though it's like a nothing. Oh, I did it perfectly the other time I did it. Now it has to struggle. I mean, I could do both of these just going directly up to that line. It just kind of communicates that they're in parallel when you do them with a little box. Let's just move one tick over. And then if I do them with a little box, then it just, you know that they're in parallel and connected there. It doesn't need to be like that, but it shows you like this capacitor is two capacitors. This, I'm going to move up a little bit. Oops. Okay, that's just packing things in a little bit so we have room to work. What the f... Why? Fine, you stay like that. Why does it do that? What the... What... Ugh, whatever, fine. Fine, you be you, you do you. I'm not gonna bother you. Man, we got a ways to go. All right, so back over to here where we have Q3. It's just each path has so much branching pathing going on. It's hard to reconcile what's going on. So collector to resistor to resistor to collector. What? Hold on a minute. Oh, and then it busts out over here to another one. What the heck? This just keeps going. Okay, so let's just keep marking it down. Marking it down, marking it down. 1000. That's 100 ohms on the emitter. So let's grab a vertical resistor. Copy it. Put it right here. Get a ground. Copy it. Put that right there. Good, good. And then change the value here to 100. R28 is born. Okay, R28 is in. Is that all we have on our emitter? Yes, it is. All we have on the emitter. That's weird. We got that. We got this. The ground. We got this. And then we go 100 ohms again out to the rest of the world, which involves another junction with another NPN that's looking like it's getting a little closer to the oscillator. These two that are facing one another look quite a bit like they might be involved in oscillation, although they don't seem to be super matched. I would assume that our oscillation is actually occurring down here in this group of matched transistors where we stopped last time. So over here is some kind of control. So maybe it's just Darlingtoning them up or something. No, they're both pulling from the same place. These here from 1504, and then that goes off in another direction. Let's make sure that's not our positive power. It's not. It's not. It goes over here. What the heck? Okay, this is a weird juncture. Well, we'll resolve it eventually. Okay, piece by piece. Get this guy in there, and let's do a 100 ohm to a junction with a bunch of other crap. So I guess I'll make this one vertical again. So copy that and place that over here. and it's another hundo ohm, so I don't even need to edit the value. And then that goes off to another junction where it meets up with more transistors. Jeez. The question is, should I branch off and do some other stuff? Hopefully I'm on the right layer. Yeah, I am. And then just to double check, get rid of the top layer. Yeah, okay, so that does connect there to a massive resistor. 150 with 4 zeros after it. 0, 0, 0, 0. Is that 15 mega ohm? No, 1.5 mega ohm, right? Get that 0, yeah, and then 3 zeros behind it. 500 and 3 zeros behind it. So that's 1.5 M going to the collectors of these two here. And those are both NPN. Oh, is this one hanging out? Is this the noise lead? Or the one that doesn't get connected to anything? Or is there a connection to that? Get the ICs out of there. Yeah, nobody connects to that lead. Unless it comes over to here, unless it's also shared. Maybe we'll need to multimeter that and just make sure. Let me do that right now. Bonk. And then multimeter on ohms. This is what I thought would be the oscillator, but I don't think it, I don't know if that's exactly what we have here. So this one here and this one here. Wait, is that correct? This thing should be, yeah, this is flipped over. It's the one on the left. 400K. So no, that does not connect like that. So this lead, I believe, is just flying. The lead that I'm touching right here. Wait a minute. But I'm getting 470 kiloohms across this device. And I don't think an NPN is going to show up as 470 kiloohms. That speaks to me of there being a resistor of that value sitting there. Why is that charging up? When I go across this resistor here, this should be the 1.5 M, but I'm getting all kinds of other interaction in the circuit. Yeah, it's like I'm charging capacitors with millivolts here. Remember, these probes are not inert. What they do is they put a millivolt signal into the resistor as part of a Wheatstone bridge that is used to detect the voltage. So as I'm probing it, if there are things like capacitors on the line, you can see them charging up. So that is indeed a flying lead of a transistor, which is typically what you'd see in an oscillation circuit. But that's not the part that's oscillating. I thought the supermatched pair was the part that would be oscillating. Hold on, let me see if I can find. There are many ways to skid a cat, but you probably shouldn't be doing that in the first place, you fucking psycho. But when you're doing oscillation, there are many ways that you can create oscillations with transistors. And engineers do a ton of different methods for that. Sometimes you leave a lead flying for certain tasks. And you see that with these transistor oscillators, these audio ones. There's another flying, well, not necessarily flying. This one does, this LED circuit with the capacitor does leave the base flying and allows for, I don't know, like noise or something. I don't know, man. What program uses PHO files as Gerber? I don't know. How do I know that? Why are you asking a streamer that question? I know Google probably doesn't have any answers, but I don't know how to fucking talk. Anybody in chat know off the top of their head? You just open a conversation like that. Damn. I'm under no obligation to provide you with answers. Okay, 100 ohms goes into this godforsaken fucking circuit over here. So now I need to start drawing this as this expansive thing continues on. There's only a finite number of traces that we will eventually get through. It's just right now we are at the tip of the iceberg. So far, our what is it, slide control and our whatever is in this area. So we know that now, but we're getting into some of the other parts of the circuit slowly. So yeah, let me start over here. And we have a 1.5 M, and then we have 2 NPNs. Those are both NPNs? Yeah. Okay, so 2 NPNs that are collector to collector on the other side of that 1.5. So what I could do is I'll put the 1.5 coming off. That one went from the 100 to the 1.5. How do I represent this circuit? This is going to get a little weird. I mean, I need 2 more NPNs, so let's copy those in. Boop. I don't know if they should go like this. I was hoping to find a little bit of inspiration from that search, but I don't know if that's going to happen. It goes through a 100, and then several other devices connect at that point. Yeah, because it goes over here to this stuff. So this stuff also, that's the base. So that actually goes to the base of that other transistor. But then it also goes to 2 collectors. Okay, I think I'm starting to see it in my head. So we'll get one of these and put that there as the base. But then that line is also pulled down by 2 of these. Where's this thing getting its voltage from? This is at best a lateral move. To here. Again, I'm trying to put this together so that it's readable, and I don't understand some of the circuits, so that's going to get a little weird. But as we put it together, you can see that I'm organizing and then organizing again and then organizing again. And, you go through these stages of things. And if you spread out, you can then compact it in later and make everything make logical sense. And maybe in doing so, you find that it looks like X and Y, and maybe that'll help inspire you to lay out the circuit in different ways. But like, this is what I'm seeing on the outset. Got 2 things there that can pull it low. Cheap viewers don't mind if I ban. Are we at cheap viewer? Yeah, we're at 40 people. We got cheap viewer bot levels of engagement. I got that one before Gonad. I've been paid to watch. Your check is in the mail, Groovy. Let's see here. So we got branching paths, and the branching paths are getting increasingly more complicated. This branching path looks kind of simple. It looks like it should be smaller on the schematic than it is, but it seems to go out to a bunch of other stuff that I don't understand. So let's see where it goes. So one of the lines of this goes to a massive F-off capacitor to ground. That would be the base, but then it also has something that's controlling the base over here. Huh. I got this. And then, oh, what are connected over here? What are doing? Emitter to... That can't be emitter to emitter. Below the circuit board, it does that. And then above, on the top, what is it doing? Maybe that one goes to the other base? Oh. Oh, they're using it as a Darlington. Oh, we have a Darlington. Okay, they're using those two as a Darlington array. A Darlington array exists because you can't necessarily switch high current loads immediately with one transistor. So you have a smaller transistor that then ticks off your larger one. Darlington array. So you would have the two collectors connected to each other, and then you have transistor whose emitter goes to the base. And that's, I think, what I'm seeing there. Emitter goes over to the base over there. Yeah. And then I can ohm it out just to make sure. I keep forgetting that I actually have the circuit here because my old job, the one that I had reverse engineering stuff, we would get sent photos of stuff. And so we'd have to work off of somebody else's shitty photos. And so that's the mode that I'm in right now. I forget that I have this whole circuit board here. This document, albeit unnecessary, it's nice to have. It's unnecessary to have this document where I've traced out all the traces because I've got the physical circuit sitting right here. This document was supposed to be a shortcut to help me work through the circuit faster, and it did its job. It's just, yeah, anyway. It did its job, it's just I don't necessarily need the full bore of this now that we're doing a full reverse engineer, but... Okay, collector to collector, both pulling this thing down, and we will make these look like a Darlington array. So these are two separate transistors that have been configured in a Darlington setup. So we can make that one device. It would be a much smaller device if we, of course, had a Darlington array component, but this isn't a Darlington array component. It's a Darlington array made out of components. So I believe we do this, and then these two, we will connect to one another. That's a little clunky. Maybe I'll just go directly off of the pin. Like that, and like this. And then, I don't know what's feeding the base there, but I want to connect to it over here, just so it looks a little bit more Darlington-y. Damn it. There we go. Bring that down and over. Yeah, I'll bring it all the way over here, because I don't know what's setting it off right now, and it looks like it goes to some larger structures in order to be activated. It's like that. And now we have a little bit of room for our other transistor over there. And now where are we going with this? This goes, and it, let's see, that base is what's setting it off. So there's a big F-off thing there setting it off. Collector goes to our source, and then emitter, well, emitter to base, and then this is the emitter, and that goes out to the larger community as a whole, which looks a little bit like it's a power line. Where are we going here? Where do we go now? Where do we go now? I mean, it's one of the legs of that test. That's not test points. Envelope mod. Yeah, this is looking more and more like it's just like either a ground, or let's just find out where it goes. Where do we go now? Where do you go? Why do you go there? Is that really where that goes? That seems odd. The plus line of a transistor. I would expect, is this upside down? No, we already determined that it's not, because we've already been through this part of the circuit. So this is coming up and around. There's our emitter. And we're going down here. We're not connecting to anything else on the way. Go up and over. And then if I get rid of the layer, the top layer, it seems to go up and under this and connects right there. That's going down and through. That one is offset a little bit, but that is a ground. But where does this then go? Let's look at the bottom layer. Okay. So does that actually go to the plus line? It does. That's a weird circuit structure. I thought it would go to a power line of some kind. But it goes to this leg of an op amp. Let's double check that. What is that? What is that? That's not the window. Where am I? Oh, I'm trying to put OBS up front. There we go. My brain got very confused there. That was a very confusing thing. This leg right here goes to the plus of one of the transistors. Does it go to V plus? Oh, it does. wait a minute. Wait a minute, it does. It just goes right, that's just connected. That one would be, is that V minus? That might be V minus. Am I on the wrong one? No, this is the right one. I'm supposed to be... Hold on, let's double check. The board's flipped. We're here. Oh no, that's the wrong one. Okay, yeah, I was testing the wrong one. We are here. We're right above this plug. This is some spaghetti that we're dealing with right now. This is just some heady spaghetti. So this is this pin here. Heady spaghetti. Spaghetti, letty, betty, betty. That is not connected. Okay. Ground? Well, 500 ohms does not a ground connection make. Man, I should pay for viewers. I should have, like, no morals at all. I could have 300 viewers and the chat wouldn't move. 2K to positive. So, That is a unique connection. What the hell? We're getting, you guys are getting paid? We had one of those view bots roll in just a minute ago. We are unraveling spaghetti, much like AI. I know, the real ones are watching and working. You guys are the real ones. I love you. I love you guys. I find it very interesting that I am people's background distraction. Now, which one do we thought it was going into like this? Yeah, look at that. It goes into there. All the way up on that header. I really like reverse engineering, but also I'm finished with work. Yeah, reverse engineering is like a string of puzzles. It's just when you're expected to get results when things start getting really stressful. Real viewer here just watching and working. Oh, wait, sorry, I already read that. Did some fighting with Java and tracing. Hey, I'm working here. I'm working over here. What are you thinking? So this is a cursed trace. This goes all over the board. We go from this op amp, what I assume is an op amp. Let's double check that. This right here. Oh, 7.2. Okay. What is this? What is the scene? What is going on? What is everything around me? Okay. Yeah, that is a TLS7.2. So that is in fact our op amp. I hit a button. It flipped me over to a weird view. Okay, so TL72. We've already worked out part of this one. So this one is associated with, I don't know which TL072 this one is, or how any of this is going to go together. All of these branching paths have branching paths. This is getting very crazy and frustrating. We're trying to resolve this Darlington right now. So the Darlington we have in, we need to put its base capacitor to ground. So that's another, that's a one off. So let's go ahead and get that on the design. Let's actually get some of these elements. I'm going to move this to another window just so that I can move through some of these elements. My explaining myself every single juncture of this thing is working against my ability to get this done quickly. It's part of the nature of the beast, but yeah, I want to make a little bit of progress on this thing. So we just need to keep rolling through. Unraveling this much spaghetti is going to take quite a bit of picnic table. All right, right there. 11. And the value of it, 1U. We get a ground on that. Okay, the emitter goes to some other accursed juncture of circuitry. So we'll just leave that hanging right now. If we get this circuit drawn out, come back and talk about it. That might be more effective than explaining it as we go along. Part of it is that as the streamer, I have to have the gift of gab. I have to keep you guys entertained with my talking. Me just sitting here doing the circuit thing. Obviously, me sitting here talking and doing the reverse engineering in the circuit only has 40 viewers, which is very low for me. It's sort of halfway of what I normally have. So this isn't very popular. We're going to be doing other stuff soon. But I need to bring you guys along with me on this journey. That's what needs to happen here. But me just sitting here silently working on it would not do well for stream. Okay, we are here. We have a lot of stuff that still has to be resolved. Build it and they'll come. They'll do what? They'll do nothing of the sort. Okay, so back to the done layer. We've got this thing in there. We got this all resolved. What we don't have is... Do we figure that out? Hold on a sec. So we have this going over to the common, and then we've got this going over to the base, and then that one goes up and around. And the emitter... Oh, lordy. Where's that one going? Something got cut off over there. Is there a via there? There is. But is there a trace for that via? Hold on a minute. That's a weird one. Look at the bottom layer. Yes, there is. There's something that's coming through here, and it gets its own little thing. But I didn't mark the trace down on this. It might have gotten deleted. Okay, so let's go back to get rid of this, get rid of this, get rid of this. And yeah, that trace didn't get drawn in for some reason. So pencil tool, make it a little smaller, go to my blue color, and then go to the bottom layer and mark it out. Oops, a little smaller. Why didn't that get drawn? Weird. It might have gotten deleted when I was messing with ICs. I might have hit delete on another layer by accident. It is a very confusing drawing, but it helps us. Where's that one even going? It goes over to this stuff, which is involved with quite a bit, but it's part of the gate system that's going on here. So that comes from below, but where does it go after that via? Because it doesn't appear to be anywhere around here. This has a place to go. This has a place to go. Let's check. Well, where can I check it out? This goes down and over and around, and it goes to... That's surely not our frequency in. Oh, it goes to this pin. I see. That's been part of the tuning pin. So let's grab this pad here and test to see where it goes up here. So which pad is that? That would be here. With a via directly in front of it? Yeah. And that goes to somewhere over here. What? Okay, so it goes to the two collectors. So that does connect right here. We'll go to our red color. Pencil. Top layer. And I'll just do that. So that we know. So the collectors go off and go on this journey, but what is... Hold on, that might be a power trace. A trace of power. Such power! Because it goes to tune. And it goes to a bunch of other stuff. Oh, like the positive input to an op amp. Yeah, so that's going to be a power trace. So let's just get that, let's figure that one out. So let me go from that part of the resistor there, this side of the resistor, and then go to positive, well, this is negative 12 kilo ohms, ground, kilo ohms, positive 1 ohm. Okay, yeah, so that's positive voltage there, and that goes to the collectors. Wait a second. And to the 1.5. I feel like this circuit is making fun of me at this point. So that is fed, I see. Huh. So this is actually a positive power trace. Is it connected to the base of Q6? Ah, come back. I didn't mean it. Come back. So this is plus V right here. Directly connected to power, huh? So this Darlington has nothing to do with the rest of the circuit. I just traced over to it. Because if those connect to the 1.5 here, they're just doing a very large pull-up for that part of the circuit. That means that over here, I've got a resistor going up, not to a Darlington array. So this is a very weak pull-up. This is designed to turn this signal back off. Wait, 15 or 1.5? It's 150 with 4 zeros. So 15M. Rename that. M. And then that pulls up. So copy this. But there's more stuff on this weak pull-up. So I need to kind of isolate this out. Other pieces of this design will get their pull-up from that, I guess. Two transistors with the same values. One of them is designed to switch the other one. That's a Darlington array. No, yeah, that's a very common thing. They just, instead of buying a Darlington array, they made one. They built it out of transistors. Okay, so this is not involved with this part of the circuit, because these two get 12 volts. Let me mark down the 12 volts too before I move on. Copy this floppy. Just like that. And then this goes here. There we go. Move this just a little bit over. I saw the diagram. Output number 3 on both transistors wound up being hooked together. I found that to be puzzling. That's because they're both pulling off the same source. So you use the one that's more easily triggered at low voltages to trigger a high voltage into your second transistor that then utilizes that high voltage in order to allow a high current to go through, basically. You're stepping it up. Very, very common. And that's why when I saw the two collectors of transistors connected together, it immediately, Darlington. Either Darlington or some kind of an oscillating transistor when you have things that are connected towards each other. What's up, RYG? How you doing? How's it going? How goes it? My butt is stool-shaped right now. Jeez. I need to, like, I need one of those weird, like, kneeling, you know those things everybody had in the 90s where you have the knee pad? Those are so common. I remember those. They're all over the place. What's up, Smith Clay? Okay, Darlington aside, I guess we'll get back to that part of the circuit. We just got freed up over here, but this 15M is also powering other stuff, which is weird, but I guess it's all right. That holds this high, and then this, so it's like These are like juxtaposed on one another. It's more like, that's not the way I wanted it to flip. There we go. More like this. Ugh. It's getting so tall. It's too tall. Make it shorter. Why is it so tall? People moved here from away, snatching up all the houses. Huh? Oh, wait, sorry. This 3-message chain. I always read the last message and I'm like, what? It's going harder than it has in a long time. We have 51 days to find a place to live or be homeless. I added lol so as not to dampen the mood. Dampen the mood. Damp the mood. Things will work out, just seems dicey at the moment. The odds are stacked high against us for dang sure. So many people moved here from away, and we read that one. Someone bought ours and are changing occupancy, meaning we have to vamoose. No, it's okay. That's on me. I need to be reading these things in more logical order. Why would you have a 100 ohm resistor on either end of this thing? That seems weird. It's like you're suspending that in the middle of a voltage divider. It's strange. Yeah, I don't know about housing stuff, man. That sounds stressful. That certainly sounds stressful. Let's go back to Q3 and Q6. These are not the two that are associated with each other. We ran into a thing where this 1.5M got positive voltage all over it. So that plus there goes all the way over to here, and then it goes down and over and around, and it just hits everything. So, let's see. On the other end of the 1500, we also have this part of the circuit, which is another one of these little transistors that's being activated by stuff. In particular, this one seems a little bit more associated with the filter. So maybe we come back to that, but it seems like it's a weird, like, source. Better than 1, 2. If you were not streaming, how long would it typically take you to reverse engineer something like this? I'd be flying through this thing right now. Right now, we're in kind of the logical part. I would be flying through it, but my ADHD would dictate that I get distracted from it periodically. In this case, I actually have chat helping me to keep working on it. You guys keep me at least motivated on the task at hand. I had a lot of trouble with taking too much time getting some circuits like this together. I'm not sure how long it would take me to do this one. This is a synthesizer. This is a lot more complicated than certain circuits. Reverse engineering something like RF takes quite a bit of time too. That's a little bit more complicated and difficult. I don't know. Sometimes a circuit just befuddles you and it becomes very difficult to go through and you know, do the work on and reverse engineer. You're looking at about the pace that I'm running though when I'm ignoring chat. So yeah. What does the circuit do? It's a surface mount. What is this thing that you come in here with, this HEG8? I don't know what that is, and I need to know what that is because you always come in here with it, and it's always weird. I need to know if I need to censor that. This is what is it? This is a synthesizer. It's a VCO for a modular synthesizer. Voltage-controlled oscillator with a filter on it that mimics the 303. Most competitive has been in 25 years for the housing market around you. Jeez. So their house for $199K and ended at $260. That's crazy. Yeah, around here the houses are stupid expensive. Okay, let's get back to what we were doing. I am now ignoring chat again. Chat, it's entirely personal. I am ignoring you. So this collector goes to that resistor, or rather it gets fed by that 100 ohm resistor. And then this goes off, it scarpers off, and it feeds something else. What does that go down to? Question mark. We don't know. We don't know. Well, actually, we could just look at it, because I've moved them to the other side of the board, so we can just look and see where it goes. So this one, oh no, we can't, because it's on the bottom of the board. Oh, but we have the bottom of the board. We have pictures of it. Oh, it just goes right into that pin. So we'll just do a little, I'll just do a little top layer manipulation here so that I can see it in the future. Can't draw. What? Pencil? Oh, because it's not visible. Top layer, pencil, just do that. Okay, so that actually goes to cutoff. And that's coming from the cutoff adjustment for the filter goes through what? Does it touch that transistor? Wait a second. Hold on, cutoff. Here. Up and over to this pin, where it then jumps to the top of the board for no reason other than to get in on this capacitor action, I guess. Come over to here, and then it avoids this thing. Oh, so that capacitor goes to cutoff. That's its only involvement. Goes over to 100 ohm. Blah, 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 blah. I've lost the thread. Let's go back to where we were, which is here. This signal going up and over. Yeah, and then it goes to the capacitor that then goes to cutoff. Strange. Syllable note length. That is, who gets that? Are there people who gets that? Do people get that? I don't. He who. I don't. That's weird. I don't. That's so weird, you guys. All right, let's bring our stuff back in here so that we know what we've done, and we're back on this just perplexing 15 mega ohm resistor. I guess it's providing a weak pull-up supply to multiple things. I don't understand that. That seems a little weird to me. I don't understand that. Maybe it'll all come together as we continue through this. The logical blocks are starting to kind of break down. All right, so aside from that, where were we? We were, where were we? We were here. So we have a 100 ohm capacitor on the other side of that diode. We don't know what interrelation did we not do of this. The 1.5 M goes other places. No, it doesn't. It just goes to a power. So 1.5 M on the other side goes to another transistor that is being involved in just about every other facet of this design. So this is not something we're going to look at yet. We need to get more of the design down, I suppose. It is confusing, though. It is very confusing, because it seems to be involved with everything that we're working on right now, including this cluster of stuff. And this one over here. Holy heck. Okay, so let's continue on and do this branching path right here. Make a nice big highlighter. There we go. And go back to piss. There's our piss. Okay. So big capacitor going to ground. This line is inexplicably torn. Oh, good. So the one that we're working on right now is cursed. It's cursed. We'll pick it up. We'll ohm it out, because I have a feeling it goes over here. Let's let me get that 100 ohm in there. Because, yeah, oh, wait, no, we were on Q6. Where's that? Sorry. Your intrepid streamer is confusing themselves, and they're going to hurt themselves in their confusion. The one transistor there, and I guess I put this one down already, and I had it going to the base, but it doesn't go to the base. Yes, it does. Okay, so we do actually have this, and then we have the transistor. So we've gone all the way up to there. I'm going to leave that alone for now and go somewhere else. So now we're going to travel all the way over to here, and I'm going to do this other branching path. So our 100 ohm to question mark. So let's get that in. So 100 ohm. Just copy whatever I can. And do the value on it as 100. What's up, Warsaber? Piss looks like spaghetti mess. Yeah, I'm pissing all over the board, but that's how we're marking what's been done already. As we move through this whole design, I'm going to put this aside. You wait over there. Oh, lordy, what is going on here? Given that we have all the room in the world, I could probably flatten this out and make that actually make more sense. I didn't come into your house. You invited me. You opened my stream. I'll say whatever I want about spaghetti. All right, so where does this trace go? We have a 100 ohm there, and it just goes under the capacitor. Does it meet up with this stuff down here? Let's see. Oh, you're talking to Warsaber. Warsaber. We're going from above and over the cap, which is here, to the lower 100 there. And we see if this one goes here. It does. It goes to the one pin of the cap. All right. Does that happen to be like a ground? No. Is it power? No. Is it negative power? No. Okay, good. So yeah, we're going to the one lead of the cap. Bonk. Okay. So we can mark that on the top layer. This doesn't need to be a perfect document, but in going through it like this, we're going to make it into one inadvertently. Whatever. Back to piss color. Bonk, bonk. A little bit larger. A little bit smaller. GIMP is so weird. I wish I could limit the range that this window gave me so that it would be a larger scroll bar. Because it's like, in this window, I can go from 1 pixel all the way up to 10,000. 10,000 is larger than this document. This slider should be a function of how big your document is. And it'll make it easier for me to select sizes like 3 pixels. 20 is about the highlighter. So I end up spending all my time in this tiny little range of values. Huh. But I guess that's just GIMP for you. Okay, smaller than 20. Smaller than 20. Good enough. All right, so we are connected over here. We go to a big 1 microfarad capacitor that goes to ground. So 1 off to ground on this line over here. So let's go ahead and grab our other big cap. Well, that one's over to the side. Didn't we have a big cap that was vertical just a minute ago? Oh yeah, it's over here. Let's grab that one, copy, and we'll pop it in just right there, and we'll give it a ground. Right there. Cool, 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 cool. And okay, so what happens after the capacitor? 2 branching paths. One is actually the base of the Darlington. So let's go grab that Darlington and bring it on over. Bring it on over, Darlington. Bring it on over. Why don't you come on over? Oh, I see. That was the same capacitor. Damn it. Delete. Delete this. Delete this. Delete this. Delete this in Minecraft. I should have known. So that goes right here. Lots of stuff going on here. What is the purpose of this? Diode 100 ohm C11. Diode 100 ohm C11, and then 6802. I assume that looks like a 2, right? 2089. No, I'm going with 6802, which would be 68K. So that's 68K, and then it goes into God knows where. Okay, 68K, and we have to see where this thing is being fed from. Down. Let's do 68K coming straight out of this thing. Right click, value, 68K. Okay. That'll help us find it later on. That's the only reason. Usually I wouldn't mark values on these things. Fadanon! The line is too squiggly. I don't think so. Thank you for 64 months. Yeah, we're doing kind of the most boring thing in the world, which is reverse engineering. It's the actual act of reverse engineering, which is where I go through and I produce a schematic based on what are there. So we have this weird sort of dual transistor that's set up as a Darlington array, and we're just kind of getting it into position and you know, getting all the connections worked out. But meanwhile, I'm pissing all over this board. It's basically marking down what we have with our piss highlighter. Bonk. Thank you so much. 68 months is... Wait, with a tier 3. I always miss that tier 3. I think you're one of the only people that does a tier 3. And it's crazy. Why would you do such things? Thank you. Because I pay him. Actually send him money. Yeah. Bonk, bonk. And then we got this one, and we got this here. We did not get wherever this thing is being fed from. We have this weird connection here, too. That goes up and over to the filter. This is very confusing indeed. I get benefits, in quotes. Ah, geez. Time for your benefits again. That would be the emitter base emitter, collector emitter. So we're flipping the switch on something big right here. And it seems like it goes multiple different directions. What are we flipping the switch on, though? We took a little bit of time to figure this one out, and I forget what it is now. It is positive. Positive, positive. Goes up here. And then, oh, I see, up and over to here. So is that plus V right there? Oh, the collectors are connected to, yeah, positive 12. Collector, positive 12. I'm just going to highlight that. Because that goes up and over to the base there with positive 12. And it's not involved with us. This is getting complicated. This is getting complicated. Our emitter goes into 5 different things. Look at where it's going everywhere. Sabon Fair is everywhere. One place it goes is to a switch. The last of the switch modules, pin 8 of the switch. Pin 8 comes out and it goes to a bunch of other bullshit over here. What the f... Uh, accent. So are we getting into accent control already? Odd to me. This is getting scary, and I think we should probably move to another part of the circuit because this is pissing me off. Because it's like, what is this? Is it a fixed voltage or not? I really need to highlight my pluses and my minuses in this circuit layout. Let's go back to the voltage layer and let me highlight all the traces that are plus and minus all the way to where they go. So I'm actually gonna do a new V layer. So do this and create a new layer. I'm gonna call it V trace. And we'll do a 3-color highlight of over the top and the bottom layer. We'll do a 3-color highlight of all the traces here. So get rid of pinouts and ICs and stuff. I don't care about that. And the top layer as well. And the stuff that I've done already is fine. We'll trace over that stuff with this new layer. So this one is V trace. Oh, yeah, looks like I markered the actual diagram too. So V trace, and then this will be our positives and negatives coming directly out of the power supply. So I'm going to take a pen and I'm going to do V negative will be in what color? V positive should be in yellow, but I need like a less of a piss yellow. We'll just do a bright yellow on that one. And so let's take positive. So on the modular synthesizer, it's negative with the stripe, ground, 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 then positive. So this is positive trace right here. Should be smaller than that. Yep, doing it. I'm doing this. Let's get all of our positive traces highlighted. And let's figure out where that's going. That one goes, I think, to here. Let's look at our bottom layer. Where's the bottom layer? Yeah. V trace. So I can trust the top and the bottom that I've already created. It's just I want to make sure that this stuff is going in the right directions here. Bottom, down here like this. Over. I've been too confused about what's positive and negative power, so if I just highlight every single trace with a plus or a minus or a ground, then I'll have much less confusion. Make sure that this actually goes there. It does, and it also goes out, up, there. And then this goes here and here. These two dots. And let's take a look at the bottom. We go out this way. We go out this way. This goes up here. This will just keep me from having to use the multimeter probes all the time. There. This one goes off to here. Let's make that a little neater. Make it a little neater. This will just help me run through the circuit a little bit faster. I'm starting to get like really confused with what's going on. Okay, so that goes there, there, and there. And then this other one goes here. I think that's it. Huh. Oh, where's my bottom? Where's my bottom, chat? Where's my bottom at? Help, chat. I don't know where my bottom is. Okay. I'll have to supplement this with top and bottom trace. It's just going to tell me, like, if I activate this V trace, I'll know where my pluses and my minuses are going directly. It's not something that should be up permanently because things are going to, like, run into each other. But it'll help me know who's what. Surely, okay, there, yeah. I was like, surely these cannot be the only places that power goes. Did I really just map out the whole thing? Oops. There's a couple more. Yeah, so that's going... to there, which goes to here and goes to here. Well, that's ground. Wait a sec. Hold on. Huh? Hey, things just got very confusing all of a sudden. This goes over here and to ground. So this is a ground. This is a ground. This cannot surely be truly one of the traces of all time. Huh? There's no way that that connects that way then. Wait a minute. What the... If that's power, then why would they wouldn't have that connect like that. Here's what I'm talking about with this crap. Oh, that doesn't connect. It just goes there. Huh? It just, wait, it just goes there. And what? Huh? This is part of the design that I think is not really vetted out all that well. It's just chilling. It's not, is it not connected to anything? No, there's no way, there's no way, there's no way. No, that definitely connects. Yeah, that does connect. It does connect. It does connect right there. But if that connects there, and then this, oh, I see, it only connects to the resistor. That does not connect horizontally. Okay. So this is wrong. Even though that's not even on the top layer. This is the top layer. And then so I need to erase this trace from your face. Where is it? Erase. Oops. Well, it needs to be erased there anyway, but hold on. I need to eyedropper, the PCB substrate, the FR4. Oh yeah, on this layer, and then we very subtly, actually a clone stamp would probably be the most subtle way to do it. So let's take, well, I don't know how to operate Gibbs clone stamp, so I'll just pencil it over, because I accidentally put this trace onto the base layer. So we'll very surreptitiously erase it. Yeah, one of the big mysteries of life. Back to yellow, back to here, back to our V-trace layer. And then I need to look at the bottom of the PCB. So that goes like this, like that, and then over to here. It's basically just going to highlight the traces that have particular values. So that doesn't go anywhere from there. Are those really all of the destinations of our positive voltage? I thought we would have many more. Oh, I see. Okay, here's the other branch. So V-trace goes up over here. This positive voltage. Look at the bottom of the board. We follow this around to here. And then it goes up here and over to this pin. And then it goes up here, over to here, where it goes there. It also goes up to this capacitor. That goes to ground. That would be the decoupler for the transconductance amplifier. Up and over to this. Goes over here. Or it sneaks its way in here. See, this is the reason that you do power and ground as your final traces. You have ground basically almost everywhere, right? Ground is always an easy way to get to. Isn't there an eraser? Not for what I did. I edited the original picture layer by accident, so I can't undo that at this point. It's possible that I could go through all the steps that this thing stores and find where I did that, but it was months ago, so it's just, I can't undo it. What's done is done. We have to live with our mistakes. When you're designing a PCB, you have a ground fill plane if you feel like using it, right? And so with that ground fill plane, you can simply just drop a via down to anywhere you need to go, right? You just drop a via and boom, there's your ground. So that would be the last thing that you would want to put on the PCB. And then right before that, you put your power everywhere, because power doesn't really care about length of traces. I mean, it can, but it generally, you don't figure like your positive voltage is going to have trouble getting all the way across your entire board. So you just simply run the power last, and that way it has this hugely circuitous job of getting to everything on your board. And it doesn't really matter that much because it can do that. It's able to do that. I think that's everyone. I think that's all of my branching paths for power. Because that one ends there, that one ends there and there. This goes up and over to there. That one goes, sneaks under these 3 traces, comes over here at the top of the board, goes to a big pad where you can test it, and then it goes over to the 5-volt regulator. This makes 5 point something or other volts. So let's take, I don't know if I should do ground. I think I'm going to do negative in, well, negative in red is not going to really stand out that well. Maybe we do it in green. Green does not speak of negative to my brain. Brain don't think of negative as green. Should probably do it in yellow, but I want to differentiate between positive and negative. So let's do like an orange. Orange will be negative. Orange, you glad I'm negative? Okay, so go across there, and then this one also travels along with its buddy. Yeah, those traces are kind of horribly. Maybe we don't do the across traces. Oh, it didn't select my color. There. Dies of cringe. I'm an entertainer. Damn it. How dare you die of cringe on my watch. Negative voltage goes these 2 directions. So we got one here. That really doesn't stand out that well. Here. Up and over. Whoops. The reason I'm doing this now is I've had a couple instances where I've been tripped up by looking for what lead is positive and negative on a device. So I want a layer that I can activate that'll just tell me where all those positive and negative traces are. And, you know, where they meet up with my devices on this thing. Might be kind of confusing, but if I keep it to one layer, then it should be all right. Down here, over here, over here, here. Not too far in. Yep. And then down, over, across, up, and then top layer comes out. Dune to here. Huh. So that's just a V minus? I guess that is decoupling, is it? That don't make no sense. Actually, I don't think that's what's happening here. So it is going over to this pin. But is this part of the circuit associated with that pin? Pinouts. So that would be one leg of tune is at negative V. Yeah, okay. But then the top layer, which we can see, we can actually look at that right now. So this pin right here, 1, 2, 3, 4, 5. Yeah, I guess tune goes between positive and negative. It's just weird that there would be, oh yeah, that is the middle pin is the negative supply of the op amp. Okay. That singular op amp. Let's say purple. I can highlight it and change the color later. Yeah, that's the negative input to there. Okay, that makes sense. So we come down here. I had to check to see that I was on the right layer. Into there. And then this continues on, crossing over that, doesn't matter. You know, I probably, instead of doing it on the crossover of the trace, I probably should just mark off like where the connections are. I guess I could just supplement it with the other layers though. Like at every single connection, if I just mark a plus or minus V, that would kind of clear things up a little bit. I've actually already sorted those out. One of them does get power. And its frequency goes to V-neg. I don't need to mark it though. We've already done that part. All right, any other branches that I haven't done yet? And I guess ground I'm just gonna have to leave as ground. It's just now I know everything that connects to positive and negative power is now marked as such. All my paths are branched. Where's that one? Wait. Blanched? Oh, I see. That's just that. Okay. It goes up and around and over there, and then it doesn't go anywhere from there. Yeah. Here. And a bunch of other stuff there. That involves ground, but that's okay. So yeah. Okay, cool. All right, so now I have my voltage traces just to help kind of clarify things for me. Actually, wait, that needs to do a yellow directly to that branch. That was branched, right? Yeah. That'd mean that whole thing gets positive power. So back to yellow. This is on V-trace, yeah. Back over to there. Okay, cool. I think that's everything. I don't think I've left anything out at this point. Negative power coming in through here. What's happening under that IC? Oh, I see. Yeah, it comes in from there. On both sides. Why wouldn't they just have... Oh, I see. Okay, yeah, that's what they're doing. So, wait a minute. What's this one? Orange, you glad to see me? So stupid. Orange over there, and then it's not connected over there. That's a different branch. That one goes around like that. Okay, I'm just trying to resolve all this stuff in my head. And that's where it jumps under and goes over here and goes over to the adjustment, and it doesn't make any branches on that path. Yeah, cool. Okay, cool. Back to work. Back to work. We get back to it. There's still a lot more of this circuit that we haven't done. Let's go back to our done layer so we can see what's going on, and then get the V-trace layer out of here unless we need it. That's just a glance trace. So I'll just glance at that trace when I need it. We are currently... Oh yeah, hit save. Control S. This, the permissions are still messed up in the file server. I need to mess with that because I can't actually save this anywhere. It needs to go on the desktop, but I need to save it on the file server so I can move over to my other desk where it's more comfortable to sit down and work on it. Oh well. Okay, so that leaves us with mostly unfinished schematic stuff. We have a ways to go with this thing, and this thing is just starting to get to be large and unwieldy, and it's going to continue on that path for quite a while. I probably should have just done one big page of schematic, and then I could break it up into multiples. But we're getting through the pre-oscillator stuff. We're basically doing everything ahead of this transistor right here. All this stuff is controlling other features. We started with our control voltage in, we have a slide input and we have a gate input, and we're exploring where that gated input ends up. I would have thought that the gate input would have ended up in the voltage control amplifier portion of the circuit, and it might eventually lead there. Right now we are just in branching path hell, and we have to see whether or not any other functionality is getting wrapped up into this thing. We could take a break from this part of the circuit and jump over to the other pieces that we haven't resolved yet. For instance, the other two switches, or maybe another one of the inputs, or we could start fleshing out the oscillator. But for now, we're just trying to get everything down on the page and get it somewhat organized, at least as much as we can stomach, and then we can bounce from there and figure out exactly what we're doing in order to organize and make everything look like stuff that an engineer would use. So we just reincorporated this Darlington array, which is when you use a transistor to flip a transistor. So you're flipping some kind of a larger load. What is that load going to? Well, first and foremost, it's going to 68 kilo ohm resistor. So we're flipping 12 volts through a 68 kilo ohm resistor, which is a pretty big value of resistor to be flipping it through, which is weird. Why would you have a Darlington array do that? Is it something like where you need to hold it very strongly? It doesn't seem like that. We're coming through a diode, our signal is, from this 22 ohm resistor that's held by a capacitor. In a way, I feel like I should probably move this stuff out and around so that it looks like it's flipping. Yeah, you know what? Okay, so let's organize this a little bit so that it's communicating this a little bit better. And we'll make it tall. It's going to be super duper tall. So this is going all the way down here, and then our two diodes are going off of this. It doesn't need to be done like this, but this is a way that we get it to communicate its functionality to somebody who's reading the schematic. Since we have infinite CAD space, I guess we're allowed to. So I'm going to do a polygonal selection. Why is polygon selection so unwieldy? There it is. Polygon selections are my bread and butter. That. And I'll connect this to here, this to here. And then this I'm going to make vertical. I'm going to finally be able to make this thing vertical like I wanted. I wish you could have this program actually resolve these things into the proper structures. Like when I flip this vertical, I would rather have this text go into a different position than where it was when it was horizontal. Shame it can't do things that complicated. Actually, this should probably go out like this. That's how we're doing the resistors. Oops. No, come back. One above that. Get this into position up there. I don't know what section this is. I don't know what specifically this part is doing. I'm not going to know until we figure out more of the circuit structure, I guess. Because, I mean, Acid Labs redesigned the M303. This isn't an M303 exactly. Or not, they redesigned the TB303. We know the TB303 schematic. We just don't know, you know, all the nuance around this thing. So this would be pulling down this 22 ohm resistor, and this is 22K. So this is easily overridden by this one, and this would be bringing this part of the circuit to 12 volts. When this opens again, this would bleed off that voltage. It's a 47 micro too. It's weird that this is there. I don't know why this is there. Maybe it keeps you from like chattering it or something. Talking in Discord and so my Discord lights up when I'm not around. I don't know what that's all about. I don't know how to feel about that. It's weird that this goes off to two different sections too. So when that flips, this can't unflip it. We have C10 and C11 holding that at a high level until it bleeds through the transistor to ground. So that would be maybe what that 100 ohm is doing. This 1 micro will bleed through the Darlington, through the 68K. I don't know where it goes from there. So let's get a little bit more of the circuit done. So 68 kilo ohms on the Darlington. That's this right here. Whoa. And then, whoa, whoa, whoa. We look at our ICs. Let me bring those back in. Another switched thing. Weird. Definitely weird. What's going on up there? That's really confusing. Oh, that just goes to ground, I see. So that goes to a via that is not involved in our... Where's my V? Hold on, where did that layer go? Bring that up to, yeah, where I can see it. So that pin is power, this one is ground. And then 68 goes to here, and then it goes to pin 4 of the switch IC. So let's bring that down. There's pin 4. Can we make that work somehow? What the heck? So when slide input is enabled or disabled, I'm not sure which yet, they're doing some with a Darlington in order to flip another switch. Weird. I'm just going to call this SW. No. Yeah, just SW. That goes to pin 4. Like that. And then this control pin is SW. What? Things are weird. So what happens on the other side of the switch? That's the important part. Because we know that pin 5 and pin 6... What? Wait a minute. Pin 8 doesn't look like it's connected to anything. Oh, unless... No, it is not. Get rid of our indicator here. Get rid of our top and bottom. Five and 6 are connected to one another? Five and 6 are connected to one another. But 5 is a control pin. 6 is also a control pin. Okay. Where are they connected to, though? And why did I have them connected to the other control pins? Oh, the connections. He's lost in the sauce. Yeah, I'm lost in my work today. I need to do that for a little bit to get anything done around here. Otherwise, we're just going to theory craft about what this circuit is doing. Order. Clearly, there are lots of connections on this thing. It's a little messed up over here, and I can't really see what's going on. If I look at the bottom, oop, there. Okay, so that is coming from. So 5 and 6 are connected, and 7 is going directly to ground. But then this comes from over here. So what I have on paper is correct. And it also goes to a bunch of transistor stuff. Does it? Wait a minute. Oh, I haven't marked any of that down yet. Wait a minute. So 5 and 6 are not connected to what I thought they were. They're connected over here to a totally different switch. Okay, so maybe we don't have an SW line coming from this juncture. Where's these coming from? It's like a branch off from something that I haven't worked on yet. Okay, all right. Plot thickens, plot thickens. Those are both connected to ground, so I don't think those are in use. So that would be 11, 13, and 14. Or no, which ones are those? 1, 2? No. 1, 2, 3? Yeah, pins 1, 2, 3, and 4. 1, 2, 3, and 4 are not being used. So this does not come from there. Bonk, 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 bonk. But they do connect to each other. And I'm not quite sure the relationship between them yet. I'll just do this. And then we have 1, 2, 3, and 4 here are not used. So I'm just going to bring them into a random spot. I guess I could put them over there. Yeah. That's power for that, but maybe I'll get back to that. So 1, 2, 3, and 4, and then the ones that are connected and go to ground are, let me get a ground over here. Not pattern. Copy. There, and it's pins 1 and 3. Okay. Oh my God, okay, stretch break, stretch break. Oh, just getting your head about you and figuring out where you are in the circuit is probably one of the harder things to do in this. Oh, cramp, back cramp, oh. That's a diabetes thing. Hold on, let me stretch my back. Oh, there we go. You gotta do your stretches before you do this kind of reverse engineering. Otherwise, you're gonna pull a muscle. Oh my God, these cabinets are filthy. I need to run a bleach wipe all over everything in this room. I was waiting for the muscle to get its head back. When you get like a muscle cramp like that, and then it just threatens you for the next like 20 minutes. It's like, ooh, you want to flex me? I'll cramp. Like, no, please, I just want to be a functional human being. Okay, there we go. Let's see. So the switches here, I thought went in all kinds of directions. Where else does the junction between pin 11 and 12 go? Let's figure that out real quick. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 11, 12 goes over here, and it goes to pin 12, and that's it. Why did I think it went anywhere else? So it goes to... Oh, wait, we're talking about the... That's the wrong one. 1, 2, 3, 4, 5... No, that was the junction between 11 and 12. They go over, and they go to pin 12, which goes to one particular switch, which is how it's connected. It's just not connected to anything else. 11 and 12 goes up to pin 12, and then that's it. I don't know why I thought that this is this way. It's apparently not. Can I just click on something? Can I? Oh, polygon select is... Confusion figure out some stuff that like other programs have just natively done since their inception, or are we going to continue like this forever? I really feel like I should drop these 3 elements down below the 2 logic gates, and then have the 2 logic gates sitting above the switched elements with the capacitors, although that doesn't really matter that much. It would just make that input CV circuit... Nah, that doesn't work. Okay, that's fine. This is fine. This right here is just awkward. These 2 lines interacting like that. I'll have to live with it. All right. So this is a totally separate switching area that's triggered by something that we don't know yet. We haven't gotten to. So far, we have slide input enabling these capacitors at either the beginning of a unity gain amplifier, a non-inverting unity gain amplifier, or putting the capacitors at the output of the unity gain non-inverting amplifier. It'll switch it between either one of those lines. When we have a signal that's over a particular voltage, and that's set by the 22K and the 10K voltage divider. So when it gets up to biasing this, it will pull down this very strong pull-up. Well, no, very weak 22K. 22K, it's a very weak 12-volt pull-up. It'll pull it down to ground. And so through the 22K, we're not using all that much current, right? And what the Schmitt trigger, this is basically like a fuzzy logic Schmitt trigger, and it's inverting. So when we pull this down, this will go up. When this goes up, it will trigger this switch. But when this goes up, this one goes down, and it will not trigger the switch. So the capacitors will be at the input. When this goes below the voltage where it triggers, so the slide in is then down below a certain voltage level, then nothing happens, and the very weak pull-up is allowed to suck away or provide or whatever. It puts 12 volts on this line, and then this will go low. When this is low, this switches off. When this is low, this switches on. And now our capacitors are at the output of the TL074D unity gain amplifier. What does that mean? I have no idea. I don't know. It has something to do with sliding between voltages, between notes, I guess. As you move from note to note, it gets bled out through this section to V negative or to ground through a 100 ohm resistor. If you have capacitors on this line, then it's going to want to swing around a lot slower, I guess. Without the capacitors, you have all these resistors dictating where the volts sit on this thing, right? And so you have adjustments on this. This is basically your control voltage that goes into the oscillator, determining what frequency your oscillator is at. So CV in comes in, gets a buffer, then it comes through here and gets either sustained or not, right? Then it goes through a little bit of adjustment and possibly gets bled out. If you do a VCO CV into there, it'll also change your note. And if you just twiddle the tune knob back and forth, it'll change the note. And that then goes into biasing this first transistor. So we haven't done the oscillator yet. We're getting there. We've got a big control section here. Now, if you want your notes to slide, you give it a signal in here. That signal will also go into the gate input for some reason. I don't know why. I don't know why this functions like that, but apparently it does. I guess it's so that the slide remains for the gate. I don't know. I don't understand. But if you put a gate in, it doesn't influence the slide. That's what the diodes are there for. They keep the externals from influencing. If you didn't have the diode here, you could have your slide input do something with the gate. It's not a complete isolation, but it does help. So, gating the input. We come in here, we've got a direct voltage divider with 22 kilo ohm resistors. So that halves your voltage. That then goes into biasing a transistor. And we're using it as a switch. So the switch is going into a Schmitt trigger, and it charges that capacitor. That capacitor is going to leave a voltage level on the line just a little bit after. It's probably not a very big value of capacitor, but it probably just smooths things a little bit. Just keeps the transistor ticking right, I guess. The 447K is a weak pull-up, so you have a very weak pull-up, and you have a little tiny capacitor here. I guess that's going to hold the line for like a millisecond until you get to whatever the fuzzy logic voltage is of this right here, and then we don't know what happens after that. If you get, let's see, if you've got it flipping constantly and you get by this capacitor, this would be a DC blocking capacitor. But then, I see, so this is bleeding out into here. What the heck? I don't understand how that would be. So that biases, and then it goes through, oh my God, and then it just gets really complicated. All right, well, let's go to pin 8 and see what's happening on pin 8, and we can branch out from there. Things are getting weird. Things are going to get weirder and weirder. We have barely any of this circuit down, by the way. I mean, the functionality is there, and we can see what everything is supposed to do, which is nice. That means that when I'm poking around with the multimeter, I'll be able to know what I should see on the other end. But we haven't gotten a lot of this circuit down. So let's get to pin 8, and let's figure out what's going on pin 8. We don't need to do it like that. We can do it on the computer. Boop. Where am I? There it is. Pin number on the, not the switch. Here. 1, 2. Still don't know what's going on with this. That technically is, oh, that's just the ground, I see. Yeah. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we are here. Are we here? Are we unique? 1002. What the We got like in the middle of a diode? Really? Right in front of my diode? Right in front of my OSHA manual? And then we're in this section now, where we left off on that one. I see. Traveling. Okay, so this is voltage controlled amplifier or gate. That makes sense. Okay, so this is where we're starting to interact with the other features of the rest of this thing. So we have this weird cluster here that I don't know quite how to represent, because we have a diode and a resistor. Why would you do that? That's a strange little piece of arrangement there. So resistor coming off of that pin, it is a 100 ohm. No, 2 zeros. So that would be a 10K, and then you have a 100K. 10K, 100K, and a diode. What the? Okay, 10K, 100K, and a diode. So it'd be like, let's take a resistor here. 10K, and then you have 100K. One hundo. Then you have a diode across the two of them. I don't know if I want it to be like, or across one of them rather. What does that arrangement do for you, though? My mama told me there'd be days like this. I have a song stuck in my head. That, like that. So you have you have like a digital switching thing, or like a 12-volt switching thing going on with that Schmidt trigger, and that would transition from high to low or low to high, and it would just be like logic, not logic level, but it would be like a logic signal. It's like a digital signal, right? It flips one way or the other. It is not analog. So somehow we have a diode here, which is, what are we, is our bias in the right direction? Yes. And there's no other connections here. I know it's a little confusing with all this stuff flying around on the underside of the board, but like this is a fairly straightforward little piece of circuitry here. None of this stuff is connecting over here with the capacitor. There's a nice clear board on either end. From there, we go over to the selector switch, gate or VCA. So I actually need a selector switch. I don't know if I have something like that. Let's take a look to see if we have the part. I would probably put that in mechanical. Oh yeah, I do have a selector switch. I have it for the VCO that I built. Little 6mm SPDT. Or I could put in a switch like these, but these don't have 3D models. Yeah, they don't have 3D models. They're nice, but they don't have 3D models. There would be a big parts reckoning if I take these and decide to make a, excuse me, if I decide to make a three-dimensional design. Trim pot. Here, we'll just put in this switch for now. Actually goes to one of the ends of it. That name is just way too big. So where does the other section of that switch go? The other part of that switch. V plus. Huh? Oh, and gate is just float? What the fuck? Okay. Okay, all right, yeah, just have it, you know, whatever, do whatever. Just do whatever with your design. That's fine. Fine. It's fine. So wait, one end is float and the other end is V plus, but our pin goes to the center. It also goes somewhere else. It goes up here. It probably activates and deactivates a different section. Through that diode for some fucking reason, but it's got a plus V on the other end. It's either float or plus V. I guess plus V saturate, but oh, this bleeds out the, no, that doesn't, because that blocks. Or maybe it can bleed out the plus V over here. What the fucking hell is going, what is this shit? Okay, hold on. So we do go to the common pin. So this mirrored like that. So we go to the common pin of this thing, and then there's also, can you get out of here? There's also plus 12. Or float. Float. But it's also, let me put this up like this so that we can have a trace go below it. And that'll represent the pulling up of that sign, of that signal line. It's the basic communication that we're making from user to user, is that we have this line here that goes and goes off and does something else. And what we're doing is we're either pulling it up or we're floating it. Because you are floating. So gate and VCA. So I'm going to place some text on the document layer, on the info layer. I had to fix my part designations. Having it do the whole $ thing is very unprofessional. So VCA or gate. So if you flip that to 12 volts, you're in voltage controlled amplifier. If you flip it to float, you're in gate mode. Oh, because I guess the varying voltage on that line is going to affect amplification. VCA could also be seen as like a cutoff. And I guess gate is just everything's gone or everything's there. So that'll float that to 12 volts. And then your 12 volts will be, what, added to by the diode? That doesn't make any sense. But that goes from 0 to 12. What a world. What a world. What a world. What in the world? Huh. Well, I guess we can see where else this is going. just to see how I should rearrange these elements, because it's not like this is a signal. This is like a plus or minus on this line. So if this went to positive, it could overtake gate, which is not connected to 12 volts, and the VCA would still operate. Whatever the hell's going on down here, I don't know. I don't know why we're branching all the way down here with that, but this thing is going to be the death of me. This is going to be the death of me. I have a feeling we're going into amplifier stuff, which is not the section that we're in right now. It's just where we are with the reverse engineering. Okay, so over here, let's just mark what we've done then. So on the done layer, bring that back in. The dunny layer, I can go to my piss yellow and do a highlighter. And then let's just get rid of all this stuff. How come tab isn't letting me hide everything? Huh, weird. Done layer, we got that stuff there, so we did this. This one's a little thick. Shit! Go back in. I pop you back in. There we go. Okay, did there, and then what else? We've done this branch up here. This. Oh, okay, so the diode's there, that's about speed. It's able to overwhelm, it's able to transmit in that direction, right? Like it can send a positive signal into this junction quickly. If it's going to bleed off the minus, it's going to have to do it through a 10 kilo ohm resistor. That's what it is. So it's able to provide through 100K, which is pretty significant. So if this thing is in 12 volts, it is a weak pull-up. But if it swings low, it has to bleed it out through the 10 kilo ohm. Weird. Just a way of manipulating the curves. All right, that's becoming a little bit more clear. If we go on this path, you know where that road leads, Neo. You've been down that path before. It leads to an amplifier, basically. All right, going down this path here, we get to a place that we've been with a transistor. Where is this coming off of? That's coming off of the 1.5 mega ohm, sorry, 15 mega ohm. And it goes to the base. Where is that part of the circuit? There's our 15 mega ohm to the base. And then we're going to, what the hell is that value? 2203, so 220K? Is that 2203 or 1203? We can actually look and see. Observe. Where the hell are we? We are 2203. So that's 220 ohms. So I got a 220. I think it's probably going to be vertical. Value 20K. And that goes here. And that goes into, please be the collector, please be the collector. It goes into the emitter, damn it. I wanted it to go into the collector. It would have been so much cleaner. Aw, man. I mean, I guess I could swap some elements here. No, that doesn't really help me. I'd have to get into the middle of this. Somehow this thing is pulling down into... Well, where's the collector go? Collector is that junction. What does it look like when I turn on the V-trace? It does not interact with that. It goes up into the filter. And over into... Oh my god. All the way into the amplifier. What the heck? Wait, but that looks like a... Oh no, that's not power. That's one of the... Oh, that's the current manipulation of the amplifier. One of the amplifier stages. Where it goes exclusively with its buddy transistor over here. All the way back down. And that goes to the collector here. And that emitter goes through this stuff and into our buddy right here. And there's a capped ground in there too. I need to put that on. Capacitor. That goes to anywhere around here, but we'll just put it right there. It'll be cute. Copy that. Well, thank you guys for keeping me occupied while I work, because it's good to have you here. You guys got me concentrating. But this is a lot of it's a lot to take in. There's a lot of complexity to this circuit. I wonder what it looks like in the notes of the people who authored the original documents, because it is pretty confusing as of right now. This goes over to the amplifier section. It seems like this whole thing could be like rearranged and flipped so that certain elements are going up and down. I find myself concentrating on that quite a bit when I'm working on, like, especially analog circuits. It's like, if the circuit is going positive and negative, I want it to go horizontal. If it is being pulled up, I want it to go up. If it's being pulled down, I want it to go down. If I have a section of a circuit influencing like another line, positive and negative, or positive, then I want to have it above. If it's pulling it down negative, I want to have it below. Like, just that logic to everything, sort of being pervasive in the designs of these things. It helps quickly communicate to the engineer what's going on. It's not just that you use the hieroglyphics, it's how you spread them out on the page and get them to communicate the functional elements of your design. Wait, what's going on over here? I think I put these down as notes and not traces. It probably functions similarly, but it's like this thing would go to, like, I could easily just have that there, but it seems like this is going to be the part of this line that is responsible for pulling it up and down. I thought it would be a pull down, but this transistor there doesn't seem to be doing that function. Can I move that over? No, we don't have that much room. Doo-doo-doo-doo. What is pulling this thing to ground? It would be the capacitor discharging. Because that would be switching in the other direction. How is that doing anything? Well, this eventually goes to the amplifier. But it's weird that it would be switching this way and not the other way. Why wouldn't it be switching a ground in? And it very clearly goes to the emitter. The section here with the capacitor. This is to ground. Now we've done this. We know where that's going. That goes to ground. It seems like that capacitor is responsible for resetting everything. Clearly going to the emitter. So we'd be switching away current, but that would go to float, and it would quickly bleed away through the 10K. Well, not that quickly, it's a 10K. If this were low. If the previous section were high, this would be low. Then we could bleed away everything through that. But then if this goes high, it very quickly, well, through the 100K still, but it, in a quicker fashion, would allow power to go in there. If I flip it to VCA, power's just there, and it's just nothing's happening. This charges up and becomes an open circuit. This is flipped from somewhere else. Does current go backwards through the transistor? Is that possible that it does that? It shouldn't. 15 M and a 100 ohm. Then that actually goes somewhere else after that. Oh no, this is it. This is it. That's all the places that that goes. So that means that we're done. Oh no, there's other places. Wait, are there? No, that's it. Okay, so it goes to those two locations. All right, cool. So that's clear. That's clear. This goes in two directions. It goes up to the 100 ohm, which has some structure here that sits below the filter. And then it goes up and around to the transconductance amplifier on the pin that is responsible for the current amplification. So the more current gets through, the more amplification, or the whatever, the more whatever. It's like a bias thing. And then this also does that. 22 over 2 here. Jeez. Where are we going? Oh my God. Now we're over here. Maybe on accent or something. And more transistors. Or more diodes, I meant. I meant to say, I meant. Holy shit. Okay, this has been a lot. This has been a lot. So we got this already. Not sure about that one. This goes to the switch, and then we haven't gone to the other side of the switch, which takes us up and around and over to... Oh my God. That same cluster. Oh no. It's like I'm trying to do this piecemeal, but the pieces are starting to blend together. It seems like for like a break, I might want to jump over to another part of the circuit and start reverse engineering that. You get a little fatigued sometimes with all of the possibilities that you have to track. Like this transistor right here is this one. And it goes to a lot of stuff. And I need to reconcile how that would be drawn in with everybody else based on how things are functioning. So I guess I want to jump to something else. We haven't even done the oscillator yet, and that's the part that's been having trouble. That's the part we're not really sure about what's going on. What's up, Adonica? How you doing? Yeah, chat's been off and on today, but I'm glad you guys are here because it's helping me. Not quite I wouldn't call it concentrate, but it's helping me author this circuit. This one's weird. I don't like that. I don't like what's going on here. It seems like this should be above this, if that's how it's doing it. But then where does this come into play? Because if I move all of this, then everybody's moving up with me, and then this would be at the bottom of everything else. Focusing is a thing. It really is. It's really easy to kind of lose all focus. Like pins 8 and 9, I don't know what they're doing. Pins 4 and 3, we don't know what they're doing. We need to kind of like take a look at them, see where they're branching off into, and see if that's an area that we can do next. So let's take a look at pins 8 and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Well, we got pins 8. We got pin 8. Huh? Wait a minute. 1, 2, 3, 4, and 5. 5 and 6 are connected to one another. Pin 4 coming in from seemingly nothing. Pin 3 being connected with pin 4, though, and that's coming from something way over here. Oh, it's another cluster of stuff. Wait, which one did we clock as actually having a... Yeah, pin 8 connected there, and that's pin 6's domain. Oh, it's not pin 4, it's pin 8. I put it on wrong. 4 goes up and around to... Oh no, it's 68K. So what do we clock on pin 8? That goes to the emitter of the Darlington? What, huh? Wait a minute. No, that can't be right. No, it can't be! I thought you were dead. Pin 8 is one of the switch pins. Its control pin comes from somewhere else. Oh. That's what was confusing about that. So this is actually like this. And then on the emitter... That's the base. Wait a minute. The track, the base. Pin 4. Okay, let's figure this out. Let's resolve this a little bit here. So pin 8 goes there for sure. Pin 6 would be the one that we don't know what's happening yet. That goes under the board and comes up over there. Pin 8 goes to emitter directly, not through a resistor. Pin 8 direct through emitter of the array. Yes, 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 yes. Okay, so that goes that. Don't call me Darlington. I'm not your buddy, Darlington. So the emitter goes to pin 8, but it also goes to something else. And it goes under and around until it gets to a non-power trace. That's right, this is what we were working on before I did all that power tracing. Power scalars are in shambles. It goes to the positive of an op amp, of this op amp. This little guy right here. And we did stuff with the op amp before. We have a 100... Is that 104? So I need the other TLO7 too. Just going to leave that there so I know which one it is. And then this is the other one, and it's all the way down here with the Darlington. Where the hell were we? We're over here. See, the drawing appears to be a bunch of switches with the ICs. To me, it looks like it would just be a mess to figure out what switch is doing what at the time. Yeah, it is a big mess, but I mean, putting it together in a diagram like this helps us organize that into functionality. And that way we would know theoretically what we should see on the line. The thing is, we have a broken device. So if whatever's supposed to happen on the line, we need justification for what we're supposed to see, and that'll tell us what's broken. We don't know that everything is functioning on this thing. It seems as though it is, but what if one of the chips here is dead and I need to replace it? That'll help me figure it out. If we have a diagram, that'll help us kind of suss out what we expect to see. Unfortunately, Dave did not give me his functional synthesizer to reverse engineer. We only have a broken one. Although by now I should have just bought him another one and just been like, yeah, I totally fixed it. It's just confusing where this is coming from. So this is traveling all over the globe Is this in unity gain? Are these two pins right here, pin 6 and 7, connected to each other? Because they go into, oh God, where are they going? They go into insane pants on headland. Envelope out. Huh. So what I'm gathering is that this pin goes to this guy right here. And I'm going to guess that pins 7 and 6 of that little guy right there are going to test as having only an ohm in between them. Picking up what you're putting down. So we have envelope out. So I can grab a connector, copy that floppy, and we're going to plop it down, I don't know, somewhere in this vicinity. And we're going to call that, and put some text on it. Env out. Out. NV out. I should probably make this text huge. But then we have, oh, you know what? Instead of doing it this way, we center click, and that mirrors the whole thing. Beautiful. That way we can have our ground down here. Ground pounder down here. Copy. Put that down here. We're going to move this in a minute anyway, but boop. So that's envelope out. Envelope out. Let's just double check to see what happens when a plug plugs into it. So ENV out is over here. ENV out, this one. And by looking at the trace, looking at the pin, just looking directly at the pin, I can see that there's no ground connection on this. So when this isn't plugged in, it's just floating. And then there's our envelope out pin, which is way up here on one of the outermost. That's the right one? Yep, envelope out. And so it is just floating. The switch pin is just floating. So that means our envelope out is coming directly from here, and it is being supplied by our little buddy right here. And that goes to the non-switched input through. I think there's through. I think we go through something. Can you guys hear the fan at all in the background? Am I good with the fan? Should I turn that down? I don't need it to survive anymore. I just need it slightly to remain alive and not be unalived by heat. Let's see. Wait, did I wrongly mark a voltage on that? I think I... Oh, what the heck? Oh, I don't have my vtrace active. That's right. Okay, I know I got it right. Okay, anyway, I'll have to double check that in a minute. So anyway, we've got our positive and we got our negative coming through here, and it goes through 1001, so that's a 1K. So let's grab you, copy you, plop you down right there. Value 1K. And then let's grab some of these, put that in there, plug that one into there, grab this signal, and we go up and around. Actually, we go down and under, but usually, well, going in on the plus, I don't know. I like putting them like this. I like it to go up and around. I'll move the text a little bit just to accommodate. I don't know, doing unity gain into the positive, aren't you supposed to have it go sling under? It's fine. I'm sure it's fine. I'm sure it's fine. I'm sure nobody will notice. Nobody will see it. Nobody will see it and judge me. It's fine. Nobody will know. They don't have, nobody needs to know. Unity gain, blah, blah, blah. We're coming in from the emitter of the Darlang tone. You can't hear it at all. Oh, that's good. Good, good, good. Yeah, it's the gate of my voice. You would hear it in the background of my voice. Concentrate on my voice. Above or below? 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 I don't know. I don't know which one I want here. Depends on what the rest of the circuit is doing. So this switch is switching something to pin 8. What is it switching to pin 8? What is pin 9 hiding from us? Pin 9, you have some explaining to do. I mean, so does pin 6, but we'll reconcile that in a minute. Man, there's too many structures off of structures. It's like, yeah, we got a line here, but it's being influenced by this. Yeah, well, that influence is influencing this. Yeah, but it's being influenced by this. Oh, yeah, well, that one is then got all this stuff connected to that, but this one has all this stuff connected to that. It's like, what the hell are these branching paths? This is crazy. Would it be easier to draw this on a 100-inch TV? I mean, that's essentially by getting rid of the frame. That's what I've done. I've now got infinite space. I can make this the size of Manhattan. But, yeah, anyway. So, some errors in this section, and I'm kind of getting through them right now. I kind of blew away a couple of things, and we're trying to kind of suss it all out. We found our envelope output, though. That's one thing we got. So I guess this line here is some type of an envelope. Maybe the Darlington is biased very particularly in order to... Huh. Strange. I think there would be more adjusting to that. I wonder if I should rearrange this to be facing downwards. That one, I guess that creates an envelope then. And this is bleeding it out. So you have positive going in here and being bled out by the 22K. And the diodes are keeping anything from feeding back into the rest of the circuit. But then you have a 100 and a 1. So it would take a while for this to get up, although not that long because it's 100 ohms. And then as that travels up, 12 volts, up, 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 up. And that goes through a 1K to your envelope out. Huh. What I'm learning is because this is a sound-making device, the circuitry may not follow normal conventions. It's true. I'm not sure what words to use to describe what I'm saying other than it's sound. Well, yeah, with like digital electronics, you're going to follow all those conventions and everything's going to be switching ones and zeros. With analog, you're going to have voltage levels, and those voltage levels are going to be added to and subtracted from. That's essentially how I see it. Conventions, and for me, conventions is a word related to how to draw things. How would an engineer put this together so that it looks like one of their math problems? But in terms of convention and unconvention and stuff like that, I don't know. Between, like, in terms of drawing the schematics, it's mostly just what you know and what you look for. In terms of circuit use, like what are we doing on this line in order to do X, Y, and Z, mostly there are certain ways to do things, you know, and you follow one or the other kind of way to do it. The reason that they would choose one over the other is because it does it in a particular way. There's like a special thing that that specific circuit block is going to do. Now, it could be that I don't know what, you know, how to express drawing certain pieces of the circuit. That's mainly what I'm struggling with. Conventions is where people dress up funny. Yes, true, true. Man, I should go to a con. I should figure out a con that I want to go to. There's like a con where everyone's just really negative all the time. I think I need to put these the other way around. I think this needs to be above. So like that's going to be in line, and then these will be pulling down from it. All right, so pin 2 and pin 5. Let's figure out where that's going. Open source? Maybe. I'll have to consider that. I shall have to consider that. Okay, so let's look at our pins again. We're getting very confused. Let's get the done indicator out of there. So we're looking at pin 8. Pin 8 connecting over to the emitter. Like that. Pin 9. Okay, going in one direction. All the way over. Oh my god, we're traveling. We're getting far away from our section. What? Where's pin out? Pin outs. Accent. And that goes to ground. And a big capacitor. Not voltage. Ground, big capacitor over to another TL074, where it then goes. Wait, that's the output? Oh, so maybe it's inverting. Oh, lordy. Oh, lordy. That's the output of everything. Oh, so this is the voltage-controlled amplifier. Okay, so it goes over to the VCA section. But I thought this thing would be doing the VCA stuff. Huh. Why would that go to the output? Is it canceling the output out? Well, we go through a big capacitor. Oh, no, we don't. No, we don't. There to there. That goes up to this crap. Down towards reactant. What the fuck? Okay. So that's the wiper of accent. So I need a new part. And it's a potentiometer. And I'm using POT US, which is a Mutable Instruments potentiometer library. I don't know specifically what she used, but there's a couple different distances for the horizontal Alps imitation potentiometer. And so I'm going to flip it and do this, and then take R37, do one of these. No, not quite. Like that. And then I'm going to put text on it and run out of room to work. It's just like, this is becoming like Steel Battalion, where you start out with a tiny little screen. Accent. Oops, wrong layer. Damn it. Hit it one too many times. So, accent control, design, trace, like that. That's on the right layer? Yeah. And then this goes to ground. And is that the only place that it goes? I'm giving myself a little bit of room up here so I can leave. So emitter of this thing, we let through a certain voltage value, and we may or may not switch it over to accent. Either way, we're going to get it at the envelope output. So accent bleeds it off through a potentiometer. Or sorry, yeah, bleeds it off through a potentiometer. Sorry, wrong one. And just to double check, we're going to go all the way back and around and back over to where we were. We were at the emitter pin 8 switches to pin 9, pin 9 up and over, around, under side of the board, does a little back and forth, a little juke, goes back up to the top of the board, up and around, takes a nice long drive, goes back into a tunnel, comes out right here where it goes to the wiper on the other board. And that goes down to ground, and then the output of that goes 2 different places. No, it only jumps under. It goes under and it goes to this stuff right here. So let's get this out of the way. And let's see, bottom of the board away. 4702. So 47K. What the heck? What the flippin' heck is going on here? 47K. Does it go anywhere else from here? No. Okay, so it's just going over to the 47 and the diode. So 2 locations from here. And then we take that, copy it. And then we take a diode, we copy it. What direction's the diode facing? Okay, so we go into the anode. A+, C-, anode cathode. What do we do after both of these elements? Which one is doing what? Is one of them going to ground? Let's check our voltage traces. There's power. Nothing's happening there. Ground is a little bit harder because I didn't mark it off. So I can instead just look at the bottom of the board. Okay, so that one is ground. That one is not. So it goes 47K, diode to ground, some other part of the circuit. Sorry, capacitor to ground, some other part of the circuit. Cap to ground. Here. Value 47K. And that goes to ground. I need shortcut buttons for placing like this kind of stuff and like changing the value and doing that stuff. That would make this a lot faster. And then the diodes its way over to 4702, so another 47K. Not a tribute. Get out of here. I could do with this program responding a little faster too. My gamer brain is very much hating all of the lag that I'm experiencing when I click stuff and it takes a second for it to actually do anything. So what is this pin here? Where's that layer? What was it called? Pinouts. Oh my god, it's involved with this entire branch. What the hell? It's part of a dual pot. It goes into one side of a dual pot? Oh no. What is that one? R? Resonance. Is that really resonance? The resonance? This one here. All these fucking connections of this part of the board. Damn. I don't have a dual pot in here, but I'll just put something in there as a placeholder for now. And that's coming from this. How does that control resonance? What's going on there? And the other end of resonance, where does that go? You underestimate me, sir. I don't know the shortcuts. I don't know nothing. This stuff, that one does connect down there. Weird. straight down and over. And yet the other parts of this thing connect on those other two. Control C and Control D. I'm not sure. Yeah, I would like to see. I'd have to look at the shortcuts. Is there a system? If you have a dual potentiometer, you would have two of these symbols, and they would be connected with a dotted line. So I don't know what I do in order to do this. If I need this to be somewhere else in the circuit, I could put this somewhere else in the circuit, and then I'd connect them with a dotted line, and then I'd know. But a dual pot, you may want to draw it in two different locations in your circuit. If you really want to, you can draw them all consistently the same and just always have a dotted line between the two. But Control D says DRC, yeah, design rule check. Copy and paste for C and V. So maybe if I do Control C, it'll... But I thought that was for when you have something connected already. Now it pulls up the copy menu. So I can do that. I can Control Z and then click on stuff. There, good enough. Just for right now. Because I don't know what everything else in Resonance is going to be doing. The one that I'm not using goes to ground, but the one that I am using goes to 3 different locations. Never follow a resonance knob to the second location. What is you? What are you? What you? That comes from here? Oh boy. Into this trace, into the filter. Jesus. Okay. Oh my God. Let's document what we've done so far so that we just, you know, I'm not floating around. Hold on, let me trace the end of this capacitor. So the capacitor does a bunch of crap. That one goes to ground, and then it comes over here. This is after the... After the 4.7K, we have 2 branches. One of them goes over to the resonance control for some reason. The other one goes to a capacitor. Is that what we've got here? Yeah, the other one goes to a capacitor and somewhere else. And so that somewhere else takes us on a journey through sound. Over here, and here, and down, and under this IC, and further down, and then for no reason at all, where it could just connect across, it pops up. Why do they do this? It pops up, and then it goes down again, and then it goes across those 2 traces, and then it's back up to the top, where it goes into a 2202 on the emitter. Oh no, the yeah, on the emitter of a PNP. That, with the base going to ground, this is nonsense. This is nonsense. That's what this is. What the heck is going on? Maybe that's a diode. I don't know. So that would be a 22K into a PNP. And have I done anything with this before? No. We got close to it, but we didn't do anything with it. Where are we? We are in the amplification section. So let's copy this thing. Do the value, 22K. And then we're going to copy a PNP, which I have a lead on. I saw a PNP around here somewhere. Let's copy this one. And then it goes to the emitter of the arrow pin. Or the non-arrow. Wait, which one is blah, 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 blah. Emitter, where are you? Yeah, so it goes to the arrow pin of that, and then the base of that one goes to ground. So we're comparing it with ground. Oops, we're on the wrong tab. Why are you dotted? Odd layout. I have all the transistors from the TB303, including several B662. Are they in TB303? Or have you had to buy all the transistors? Because that's kind of where I am. This is plain old, what's this? Control D, plain old V set to value. Oh, really? So I could just hit V and change the value? No. Yes. Oh. Oh. Snappy. Okay, if I can remember that. So Control C and V will get me by. Hey, thank you, CS Strachan. CS Trachan. I saw this dude dress up as a goblin and roll weighted dice with people, but he rolled dice that always lost. That's like the terrible luck build. Procrasticon. Yeah, I think I'll go next year. This is something that I've only seen in these like VCO and stuff, the modular synthesizer stuff. I've seen this before, where you have the base of a transistor going to ground, because everything is just voltage potentials. So technically, setting that to ground is akin to having a positive 6-volt signal in a 24-volt system. So, you know, it's just apparently a method of doing stuff that gets you by. It gets you by. ML303, V3, and that's crazy, dude. Those are some crazy pieces of equipment. I forgot about the Expo converter, but the VCO, it's, oh wait, I forgot the Expo converter, but the VCO itself are 3 transistors, and these don't have to be matched. I thought you wanted to use the CA3046. I don't want to use, we're reverse engineering what they did use. So we have the M303 that is broken. And so I'm putting together the schematic in an effort to be able to know exactly what's going on this board and run through it and figure out what's going on. So this will help me troubleshoot this circuit. I do not have a lot of knowledge about how the TB303 functions. And this is helping us kind of focus in on specific little areas and see what's going on. And it's fun because we get to raise a bunch of different weird questions about what's going on. It's like, what the hell are they doing here? Like, Accent is bleeding this trace down to ground. This sequence of operations. Resonance, I don't know if that's going to be like our output or what. And then we got something going on over here on the transistor. There's not enough information yet. But like the switching stuff is what I was really trying to get to the bottom of. Like, what is this section? We switch it on, and it influences the voltage level at this TL072, which is also our envelope out. So it's, you know, slowly but surely we could build up an idea of how this thing is functioning. So I need to mark down a lot of stuff. We got through quite a bit there, and I don't want to get lost. We're always in danger of getting lost. This stuff goes somewhere else, but let me get the pencil out. My pencil. And go to the done, and so now I can just highlight stuff that I've marked off with piss. We're gonna piss all over this stuff. Get our piss on that. Mark it off as piss. Up into there and over. And then over here. All the way back to our, well, actually we're avoiding the big boy. Come over here to this, and we got that done. We didn't get wherever this thing is going. Oh, no, we did. Yeah, that goes to ground. Right. And then we have this coming back over here to the resistor. We got the diode in there. Got this in there. We trace that back down to that pin. Not much further. What was this one? Volume. Oh, accent. Yeah, we got accent. We got accent. That's what led us here in the first place. And we go down and around. A lot of the elements of some of these things, they seem to like wrap around the entire circuit board. I wonder what their design process was. How many revisions they had to go through. That leads us to pin 8, or pin 9, and pin 8 is spoken for. Whew. Remember those toys that were tubular and they made a funky sound like a plane crashing, but more synth style? I think that's what a bleeding circuit does. Huh. I don't know. I don't know if I remember the toy you're talking about. I know there's the cow mooing tube, the moo tube. You put up and down. That accent control and bleeding off to ground sounds to me like a way of decaying the sound. I mean, that's what the. I think you're correct about that. What are we saying? Lost the schematics of the ML303. Potentially signal isolation because you're dealing with sound, and also they have a lot of pathways that seem to cross the board on one layer. So they had to go underneath. Yeah, there's even parts of the circuit board you can see where they've dropped a signal down with vias, and there should be a trace going across it, but they did a revision of some type. And so there's no longer a trace that goes across it, but they still have it dropping down to another layer. I hope they weren't in a rush when they did this. Used to reverse IEDs, yes. It was nowhere near as involved as what we're doing right now. I mean, there was that level of, authoring circuits and stuff. It's just what we're doing here is supremely complicated because this thing does a lot of stuff. It doesn't just flip a switch. We had some very complicated devices in that job, but yeah. Back in the olden days, oh yeah, I remember those. And I took my horse-drawn carriage to school. Life support equipment, damn. With electronics repair. Yeah, there's a whole class of devices that are on another level of reliability for life support related stuff. That's crazy, man. Sounds fun. I had an offer to work on CT scanners in like Colorado or something like that. And it was like just from like a conversation I had with somebody on Reddit. And I was like really considering it. I was like, that sounds like a good job. I wonder what my life would be like if I branched that path out. Such is life. What is this one right here? Accent in, huh? I think we probably need to figure that one out. Where's that coming from? Holy shit. Oh, this is from another, yeah, this would be the accent pin. All right, well, let's figure that out. Accent in, because that's going to relate to some of the other stuff. Copy this. What's going on? Uh-oh. CAD's being a little slow. And then this one would be here, and then I would do a label on it, call that accent. Put that right there. We need a ground. Telling the keyboard shortcuts is a lot faster. That, and then we need text on the outside. Document. Keep it short. Hack in, right there. There's our accent in. So there's our plug. Plug coming from the layer there. And we also have, this is coming from the other page of the diagram, the one that we can't see. That's the third signal that you can cut off if you feel like. And we go up and around. You can install a six pin jumper there, and that allows you to either take an internal signal or get it externally. Up here, and over, and up, and up, and over, and around. By God. Ah, where are we? No. No. What happened? It did like a linear scrolling thing. Accent in. So from the front panel, switched, goes through the socket, and now we're here. That comes over and around and down. Maybe not so straight-edged as that. Over to here, and down. The plug is basically a switch, so when you plug it in, it cuts off the internal accent control, and it gives you external accent control. And so we go under the board, and over to here. And now we are at this little fun little array. This fun little array. This is fun. We got this fun little array sitting here having fun on our circuit, and everything is fun, and it's just so much fun sitting here with this array. 2202 is a fun value. That's 22K. It's just very fun. 22K. So 22K coming off of this. Wrong tool. I see the line and I go to click the line. My neuron activates. Oh yes, we're having fun. You finished the diode disaster? It's starting to become a little bit more clear, yeah, what's going on. Keep the production guide allowing to set up an area for me to do board level repairs or work from that starting position. New product well over time, held my own. Nice. Also, as a lead for production line when something is broken. Oh, that's gotta be ridiculous. Main job repairing the ventilator. Oh God. Nice. Well, it sounds like you got to do a lot of different things. I think the variety in a job position is one of the more important things. You want to be able to jump from thing to thing, and it makes your day a little bit more varied. Because man, if I get repetitive stuff, I start to really shut down. That's why this stuff is so great. It's because every single section is a puzzle. Training, blah, blah, blah. Crap, it's still here. What? What do you mean it's still here? Yes, of course I'm saying, hey, Sub-Zero, how you doing? Blah, 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 blah. Okay. I hope no one has to reverse engineer this. Environmental chamber distress test. I almost got a job doing environmental stress testing of aircraft components. They had a chamber that you could just set to be like really humid and hot. I can't do repetitive, but I could do this all day. We tend not to do this on this channel, although we do quite a bit of sort of forest gazing in terms of reverse engineering. This is the first time in a while that I'm doing hardcore value for connection for value reverse engineering. Generally, we just fly over and say, oh, this section probably does this, and wow, this is a unique little weird thing that they did over here, and stuff like that. I try not to bog down into these minute little details, because the general consensus is like, oh, this does this does that. We don't need that level of detail often. Although here we do, because I'm trying to very specifically repair certain elements of a larger design. So, okay, we've got our 22K. We have 1002, which means 100, 2 zeros on the end. So basically knock a zero off of it, 10K. 10K is going across the input. It goes from base to emitter. If we pull in the top layer trace, yeah. So, and then the emitter is on ground. On God. So we're going to copy this one. And we'll throw this thing over here, and then we're going to get an NPN, which I believe we have not touched this NPN yet. This one, it says it's U2. That's actually a PNP. We want an NPN. Q2. Copy. I'll have to repair these parts and have them name themselves properly. Just like that, our accent input is going to tend to go to ground because it's got a weak pull down. We can overcome that, although the weak pull down is kind of part of a voltage divider. So maybe I need to actually treat these as a voltage divider and draw them in as such. Because the bias of this transistor, whatever 0 to 5, 0 to 8, negative 8 to positive 8 volts, biasing across 22 to 10. So a 2 for 1. I don't know. Anyway, all right, back to the circuit. Jesus, I love minute details. Oh my God, the details. To ground, to the base, the track's the base. This is positive? Why do I have that marked as positive if I didn't trace, well, I guess I didn't trace any positive to this section of the board, so there's some error. There's some error in my V-trace. I missed something. I think it's right here. If that's positive, then it permeates through to everyone else. That's a correction. That's actually on the lower part of the board. Okay. Also acts as the control like on an op-amp. Let's recraft when we've got more information down. There's some error in here and I missed something. I think that's under the board. It takes a left towards Albuquerque. Oh, and then it actually, yeah, it pops up right there. So I didn't finish this. So we need to go back to neon yellow. I need to go for a slightly smaller size. And we need to follow this around and mark off. What would this one be tracing? I think that's tracing something else. Weird. All right, so there, and then it goes under the board here, and it connects to this pin, and it also goes out to here, and then this is where well, why would that be? Oh, because it's two separate branches. But where is it going? I don't think it's connecting there, is it? Maybe it is. I guess so. So it goes over to here, and this is a positive V trace. And that's the other side of a big resistor. I think that's one of the ones that blows up. And there's the thing there. And then I think that's done. Oh, and then it goes up this way. And goes to here. Goes to here. This is on its own layer that I can just pull in. That'll help me highlight what traces are positive and what traces are negative in order to avoid confusion. That would be the positive pin of the op-amp. It goes there and it doesn't go anywhere else. And I know it's very spaghetti-y. This gets very, very spaghetti-y during the process. But see that? That's where we're working right now. So that's why I wanted to correct this. Okay, there. Now it's gotten everywhere. The only place we don't have a lot of positive power is up in here. Oh, gonna make me lose my mind. Up in here. Up in here. Like, this is the source for the entire ladder filter. My head is spinning already. This is why I'm leaning towards digital and not analog. Though I do admire this, it's like looking at art. Yeah, you end up with something that you could put on a poster if you have like a screw loose. It's just like, I mean, I'm just going over somebody else's design. The level of complexity is pretty high here. They basically started with design documentation. Like they probably had much more organized and easy to follow schematics. Why did you pick the tower next to my apartment to kill? I have phone calls to make. I'm sitting in a neighborhood that has no cell phone reception at all. There's nothing. I can get edge on if there's like a breeze. Maybe some of the wibbling waves of RF can barely even make it through, but by the time they get to me, they're like, and they just die. I don't understand it, and I've got a really good cell phone plan. I can do cell phone streams very easily because I have tons of data on my plan. I have that grandfathered in infinite data plan that I don't use. I don't know why I'm paying for it, but it's like the only expensive thing that I pay for. Never lived in central Massachusetts. Well, I wish I had better reception on my phone because my phone can do all the cool stuff, but I mean, like, getting to a design like this, there's a lot to it. This level of complexity does not happen overnight. This is a big design, and Roland had pieces of design, facets of other designs that they wanted to combine together in order to make a synthesizer module, a voice for a synthesizer. And so they had particular ways of doing stuff, particular ways of structuring circuits, and just basically, their own internal design files. And so they pieced all that stuff together in order to make their iconic M303. We are on a different leg of that, and we don't get access to all of that stuff, all that information. And so we have to kind of scramble together in order to put circuit structures together that are accurate, but they might not communicate properly what these different facets of the actual device do. And that's where our expertise is required. That's where we are sort of the expert. We come in and we say, well, this kind of looks like something that I've seen before. Let me research that. Let me look that up. It is a lopsided design it's a lopsided process. It's not easy to follow. But I'm doing my best, and hopefully you guys will get a little bit of good information from what I'm doing here. So let's get the rest of this transistor in here. This is not a PNP, this is an NPN. And I tested these. I diode tested them, or I put them in the transistor tester that I bought in order to make sure that all the transistors are good. Now, it's possible that we do find one of the other legs of these transistors might be bad. I haven't removed every single one. I've only removed the ones in the filter section because I thought we had a filter problem. And I guess I'll use the signal generator at some point to put a signal through the filter and see if we get a response on the other side. I need to get an audio output that I can listen to on that filter, or just get a good way that I can test it. Because I tried to put noise into the filter, and I put noise into the filter, and I looked at the frequency response, and it didn't really I didn't really get the results that I wanted to. So we'll have to figure it out. The only place I don't get reception is the smoking shelter at work. The government jobs that I've had, the reverse engineering IDs, the facility was a Faraday cage intentionally. So I once characterized a little clicky remote, and I got to use the FBI's RF chamber. And what it is this huge warehouse with these very long blue square cones that are designed to reflect RF amongst them and dissipate it. So it looks like, if you have like an emitter in the middle of the room, it's emitting and it's not reflecting back in. And so all these cones and everything was just super duper hyper quiet. And then they had on an arm an antenna that they could rotate. And I stood on a rotating table. So they were able to spin me and move an arm in an arc around me in order to characterize the emission properties of a little clicky remote. It's pretty cool stuff. They can drive an entire SUV in there and do all the RF testing on it. So 10K, we got that one. That goes to ground. This thing goes to ground over here. We got that. We have our transistor in there. The only thing that remains is on the output, we have a, what is that one? That one is the trace, and then pinouts. No, not pinouts. I want the top layer away. 2202, never have I seen that value of resistor in my life. So what we have on the emitter is a ground, and then here we've got a 22 to 12 volts. So copy that, put that here, copy this, put that here. We can move those in a little bit. And then we have 12 volts. Put that over here. And then this is the output that goes to our next Schmitt trigger. And that Schmitt trigger is living all the way up here. By the process of elimination, we can assume that this one resides, it did a weird thing, on pin 5. Is it the 5 pin? Let's check. Pin 5. 1, 2, 3, 4, 5. All right. Cool deal. I don't really need to trace it up into that. I can just go in there like that. And then that gives us this. Goes to positive. This one here and that. More of the circuit has died. Yeah, that's what it... Oh yeah, I copied a 22. $22K. Weak pull up, gets pulled down by the Schmitt trigger. No, Schmitt trigger. Yeah, Schmitt trigger. Yeah, Schmitt trigger. Whatever, the fuzzy logic. Wi-Fi dies, cell dies. What's that? Oh, presidential motorcade. Yes. It's more than signal jamming. It's more than signal jamming. If you knew what tower your phone was connected to, you would be able to see that it's connecting to a false tower or something along that nature. There's some crazy stuff that those SUVs do. And it's like, I don't know what they do. Even in spite of working at the FBI, like, everything is compartmentalized to a very high degree. So anything that I'm saying is speculation. I don't know actually what the presidential motorcade does with RF. Probably some nefarious shit. Oh my God, this thing just keeps branching out and branching out into larger and larger circuit structures. This thing is fractal as shit. Where do you go? Circuit. Where? What will satisfy you? It appears as though this is jumping over in a weird way to this pin here. And that leads us across the board to the ground pin. No, it goes here, which goes to the junction of pins 5 and 6. Are those really connected? I guess so. Pins 5 and 6 are both triggering 2 switches. So let's get this and let's move in over here. I mean, technically we could go up here like this, but like if I really smash this in, we might be able to get it even with everything. Yeah, I guess so. That's a little compact for my liking. Having all this stuff very spread out would be nice. Pins 5 and 6, which are connected together. Huh. Where did that 68K come from? Oh boy, we haven't gotten back to that yet. That's going to be a little bit confusing. I'm going to have to figure out where that 68K is. We ripped it out of some stuff around these. I was in New York City when Biden went on the UN building there. I was walking up Madison Avenue when my Bluetooth died. turned around and saw a police escort and 4 blacked out Suburbans rolling up the street. For a while on Alibaba, they sold all these cell phone jammers, and those things scare me to fucking death. Because those would be my death. Because if I wasn't able to get Bluetooth, there goes my insulin pump. That's like frightening. I don't mess around with jammers. I have a cell phone jammer. It's illegal. It doesn't work. It was from like a cabinet, but it's a SparkFun product. It has SparkFun's logo on it. It's this little credit card size thing that's multiple circuit boards smashed together, and it probably has one of those irresponsible amplifiers as part of it. But that's not a legal device. You can't use it. SparkFun sold them, but it probably only blocks analog cell phones. It's probably not great with digital cell phones. How do you organize this thing? Good Lord. I'm gonna hit Control S. Well, pacemakers, I believe external communication on pacemakers might be Bluetooth, so it might not be that big of a deal if it loses contact. For me, I get microboluses, so I get like fractions of a unit of insulin. A unit of insulin is like a fraction of a cc, like a cubic centimeter. It's a volume measurement. So I get a fraction of a unit minute by minute in order to keep my glucose level under control. That mimics how your pancreas actually delivers insulin into your body, and it helps you save insulin, actually. So I get that because I'm a big, giant, fat ass, and insulin doesn't really affect me all that much. So missing a couple microboluses isn't a death sentence, but if Joe Biden drove by, if I was like, yo, is that Joe Byron? Then I could potentially go hyperglycemic if he was around for like an hour. That would be very annoying, and it probably wouldn't be that life-threatening, but still. Yo, Joe Byron, hold on one second. I gotta go get insulin. Do some devices get whitelisted? It's possible. I mean, you would want communication takeover instead of just like, yeah, I don't know. I don't know how that would work. Okay, so accent control was nice and easy. It's weird that it functions like this, though. There's no front panel accent control, is there? No, there isn't. There is VCAN. Accent in, yeah, is below gate. So I guess it functions in a similar manner, but gate is over here, goes into this structure. Accent is over here, goes into this structure. Somehow they relate to one another. Jeez. We got the last one of our little switches sitting all the way down here. And then I have the device profile from the FCC registration. Could use that to whitelist the device. They don't even need it from the FCC profile, just from the Bluetooth standard. Just from Bluetooth standard, you could figure out what every device is. At least Bluetooth Low Energy standard. But I don't know if Joe Byron is doing that. I don't know. Joe Byron might just be putting out a bunch of frequencies, just naturally. He just does that. Pins 4 and 3, because 6 and 5 are apparently connected together. So there's one more of these switches. I did not think that they would be using this full switch device in an analog synthesizer, but they're using the whole switch device in this analog synthesizer. It's a mad, mad, mad world. So I want to figure out what pins 4 and 3 are doing. Oh, but I also have to mark down what I've done so far. Oh, Jesus. This is a mess. This is just a mess. Pencil and this layer, and I did this, which is also this, and it does not connect to ground. It connects to pins 6 and 5. Okay. This is a nightmare. This is a total nightmare. We're getting through it, though. You can tell they're starting to merge across the board. This would be the oscillator. This section here is what's oscillating. Here's the filter. And here's the voltage controlled amplifier. So this section right here that we just did is gate and accent. Pretty cool. We now know the different like areas of the board and what they're precisely doing. And it is very modular in a sense. That is us getting into the head of the people who designed this. They said, well, we've got this section. Now we need to do this section and this section and this section. Now we need to connect them all together. Oh no, this part doesn't fit. Let's put it under the plug. And we can tell by the symmetry, the overall symmetry, that they designed that front panel to be in a particular way and then routed the front panel to the headers. And the headers they have symmetrical. So that was one of the initial elements of the rest of the design. Here are where the headers are. We're keeping them right there. And then it seems as though they had to do a shift of both headers a little bit to the side. So if you plug it in upside down, the screws don't line up. But they might have originally had it completely symmetrical, which is really under my recommendations for Acid Lab. I would double underline, do not make the board symmetrical. This kills the board. It's fucked me over. This fucks the user. Don't do it. And perhaps they could have made a little bit of room in this area right here. Maybe scooch the header down a little bit. Scooch the header down a little bit and put a 10-pin connector right here. Because you're right next to where you're going to get all of your voltages and stuff. So if you just kind of push those circuit elements out and around a little bit, just make just a little window. Although it's probably here specifically because it's in exactly the spot on their other modules. Because their other modules, they want a daisy chain. So they probably want that flat cable to be plugging in at the same height. So maybe they couldn't move it, but they could have probably dredged out this area just a little bit so that we could have a 10-pin connector with a shroud, a keyway around it. That would have been nice. That would have kept Dave from blowing up the synthesizer. And then I wouldn't have been able to get all of this wonderful information from it. Perhaps I have misjudged you. Okay, which ones are left? What do we need to figure out? It seems like pin 3 is the only thing we haven't touched yet. It's 4 and 3. Yeah, okay. What are pins 4 and 3 involved in, aside from vehicular homicide? Let's see. 3 and 4. 4 is go up. 4 is go up and go to 68K, which come from base. Come from base of Darlington. 68K through here. Where Darlington? Darlington. Their base. So this go up here. Too many crossing lines. I don't like it. Why? Why would you operate like this? Okay, double check what I'm seeing. Pin 3 goes up and over to something cursed. Yeah, it's going to some front panel control. So that has a journey to take. But we have... Hold on a minute. So this 68K goes to this junction here, goes in two directions. One of them is to a switch, which is on pin 4. Pin 4 there. The other direction goes up and out and around and over where it hits decay. Okay, so here we are in decay land. The land of decay, otherwise known as Detroit. Let's see. 60, so on the other side of the 6.8K, which we have in the board, but we've disconnected. So now we know where this thing goes. Like so. And then I need just a little bit of room over here, which I can get if I move all these. So we grab all this, and we just scooch. Maybe 2 scooches. 2 scooches will do. 2 scooches. And I can take that out from there to there and to there. Where else did the 6.8 go? Oh, to decay. And DK goes between those two and... Oh my god, it goes all the way around here to the 0 ohm to this cluster that I've been avoiding. That leads us back and around over to pin 3. What the heck? Oh my god. Okay. What the fuck is this stuff? Okay, all right. All right, we need another potentiometer. What? It's like, woo. Easy to spoof a device if you can just whitelist an entire category. It's like cybersecurity. You can't whitelist Microsoft.com because somebody can spoof the domain. Yeah, it's, I mean, the standardization, but... Oh god, where is this gonna reside? I guess I'll need to, let's just move all this stuff down. There'll probably be a more logical way to lay this out. It's, yeah, it's crazy. We're doing loops around these other things. There's woo. It's crazy. All right, so that one goes to 68K, goes to pin 3. Try to figure this out and try to get this in here. I mean, to be honest, like, I don't need to be minimalizing the size of every... I could have these circuit elements be, you know, spread to the wind and have plenty of room to operate. We're really after functionality, not readability, although I am making this specifically so that I can follow it and test these sections. But again, I don't need to minimize this. The minimalization of the circuit is just something I do naturally. Okay, boy, oh boy. Pin 3, and then where do we start from? We started from, oh, that's right, I need a potentiometer, an accent potentiometer. So put in another one of these. That, and we tie 2 of the pins together. And take the label, that here. And then we go into our document section. I guess I could set the value as accent. I haven't been noting down what the values of these potentiometers are. I'll probably need to go back through and figure it out. Okay, so pin 3, where do we start this from? We were somewhere else. We were on like... I forget. All right, let's just go from pin 3 then. Pin 3, up and over here to a diode. We were starting from some other logical jumping point, weren't we? I don't remember. I don't remember. I remember that it took us up and over to accent. I'll start there. Sorry, decay, rather. I called it accent. It's decay that we're tracing. Decay comes down and over and around and from pin 4. Okay, so pin 4 goes to decay. George Decay. Pin 4 up here, over, around, and above to the end of decay. So pin 4. Wait, pin 4? Double check. Oh, 6.8 goes to pin 4, which goes to decay. Goes to 4, and then that goes to the accent control. Or no, I called it accent, it's decay. DK. Decal. Do it like this. Is it 68 or is it 6.8? Usually you see 6.8, and I don't know why. It's probably just like a common mathematical thing. or one of those things where you're like, I need a resistor in this range. This is the most common one. So I'll just do that. It'll be close enough. I'll double check the value in just a second here. So one of the priorities here is just to get stuff connected. You just connect it. You can rearrange it later. And maybe sometimes it makes more sense when you put it down on paper. Like this, I do not like that. I don't like having so many lines crossing over one another, and it's likely that we'll be able to actually rearrange this stuff so that it's not so busy. That's probably not the answer to this equation. Cool. It's looking worse. All right, so from there, looping around, that has to do with tolerance. One value plus or minus is tolerated, bumps into the next value. Yeah. The E series of components. What, is that the most popular car in the world? Isn't that the 330i? That's the most popular car in the world, I think. Top of the board, up here, over here, and around here. And we go from pin 4 here. This does not look like a lot of trace, but when it comes to actually putting it on the board, that takes us up and around and over through here. Up we go. We continue to travel around different elements of this design until we get to this via, and then we juke over to here, and then we are at the beginning of the decay knob. Now, the other side of the decay knob, we're coming out here, we're going to a via, we're jumping under those two traces, and then we go to something that I've already done. This one would be the accent, and we are looking at, no, we're actually going under it. We're going under this whole area. Oh God, and then we pump out all the way over here. So we've now gone on a semicircular tour to get all the way back down here, over here, to a 0 ohm resistor. So we're going to pump a 0 ohm resistor on this thing, which is just a jumper. I'm still not sure where this is going to lead. Ohms. Right, yeah, you get as near as you can to the value that you want, and if your circuit is tolerant enough, you can get away with it. This will be heavily rearranged in a future revision, but I think it leads back to pin 3. So we've got another structure of diodes, and it looks like, I don't know, maybe this is like limiting. Usually when you see diodes like this, it's, well, okay. Let's find out what it's doing by reverse engineering it. That's generally what we should be doing here. This one leads back to pin 3. So this is the connection to pin 3 right here. Pin 3 is doing a lot of stuff. Okay, so 0 ohms, and we're coming into this section, so we're going to need 3 diodes. So let's go ahead and bring this up. And let's copy that floppy. Let's start our diodes. I'm going to draw it over here. We'll see what it looks like when we're done. It's a madhouse of circuits here. Copy. 1, 2, 3. And let's see, what are we doing? Now, are we branching to other parts of the circuit? No. We've got them connected in a very strange way. It looks like we're dropping the voltage through one of them because we're going diode to diode, and then we've got resistor to stuff, and then that diode goes to ground. So we are diode, 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 ground. So we're going through 2 and then out 1. So like this and this. Oh God, I'm gonna run out of space very quickly. Move down. So like you, and straight through here, and then the next one goes to ground, which is over here. Why does Control-Z take so long? You wonder, because you start approaching crash time with these programs where it's no longer able to tolerate your bullshit, and it decides that it will fail and make you cry. These diodes are very clunky and large symbols. I think even my LEDs have a better symbol to them. Okay, 8, 9, 10 to ground. What are you talking about? Oh, M fasteners? ISO 3 standards? Okay, boop, boop, boop to ground. And then on our output, we have 2022. I've never seen that resistor before. And then about 1,000 other connections. Oh, God. So 22K. Grab this one. Whoa, they were both selected. Weird use of a diode to drop the voltage like that. And perhaps I could put that vertically over here. Just have it come down off of this. But it's going to connect back over to pin 3. Where does it connect back over to pin 3? I think at that resistor it connects back to pin 3. Yeah, it goes down and connects back over and to about 1,000 other things. What the heck is going on with that signal line? Oh, it supplies the filter with power. What the? Is this a power branch that I neglected? Have I misjudged you? It sure does go to a bunch of stuff. Oh, that's ground. If I'm to believe that. Goes up and over to here. The pin that we would be looking for. No, that is a ground. Okay, so that's a ground. Wait, no, why would ground travel that much? It's not like there's a giant, massive ground plane on this entire area. No, that's not ground. That's ground. This is something else. Oh, it's 5 volts. Oh, okay, so that goes to 5V. Okay, so that resolves that one. Yeah, 5.3 volts is another supply on this whole thing that they make specifically for comparison reasons. So that 2.2 goes up to 5 volts. So what the fuck is going on with this control over here? There's something else that I haven't figured out, and it's getting confusing. I think I called that. It was in the schematics section. Schematics, and then it was something like, oh yeah, I just called it 5 volts. I didn't bother with the 0.22s. All right, this is getting confusing. Parts of my circuit are stepping on other parts of my circuit, and it's getting hard to trace out what individual things are happening where. Oh, that doesn't do 5 volts at all. Wait a minute. Well, no, this is still 5 volts. Does that go to 5 volts? That doesn't make sense. No, that doesn't go there. No. This goes here. Like that. But then this might just be an artifact of my drawing, because those two go to ground. So this would go here with the 5 volts to 3.3, and then it would go into this part of the circuit, which is some kind of an op amp involved with the oscillator. Okay, so this little flub of drawing has caused much confusion. Oh, unless, hold on a minute. No, it doesn't go over there, I don't think. I don't want to like erase it because we can't see under the ICs right now. We did look under the ICs at one point. But like, this is kind of confusing. I don't know whether or not that means that this pin is connected, because this is connected to ground. So why would you do that? You wouldn't be routing your ground all over the board. So I don't think that's a connection. I think that's an error. You're coming up and over and around and all the way up to here to where we're working, where we have our 3 things, and then this. That goes and it flips to the top of the board, and it goes under our diodes and connects to that resistor. And there's our 0 ohm, and then this goes over this way where it goes to pin 3, which is a switch. If that is 5, that's not 5 volts, that would be, hang on a minute. Pin 3, up here, over to this junction with a 0 ohm resistor on the diode thingies. So that actually connects to here. Somehow that's supposed to control decay. I don't know where it's going, but man. Oh, Jesus. Okay, we're at closing time. There's so much more to resolve with this circuit, and there's a lot of organizing to do. We've just started to get into the real shit territory where things aren't going together as logically as we would like them to. I mean, you start with your head in the clouds. You have all of the aspirations of a young person going through life and figuring everything out. And for a little while, things are nice and neat and organized, and you start to realize that things are functioning in a particular way, and you're able to go through and reasonably suss out exactly what's going on in your circuit. But then the complexity starts to build, and as the complexity starts to build, you start getting into horrible, horrible things that you don't understand, and maybe everyone around you is plotting against you in order to confuse you, and it's not your fault, it's them. They're the ones that are gaslighting you into thinking that your entire existence is meaningless and dull and stupid. And you get into more branching paths and more interconnectivity, and everything is so complicated and stupid, and okay, we just need to take a break. This is getting crazy. I think as I look through the working schematic a little bit more, I can probably start to identify different areas. This is looking very little like the M303, because this is all the parts of the M303 that I didn't have anything to do with. I haven't looked at, all I've looked at is the oscillator and the filter. So as we get into the filter, as I get beyond this transistor right here into the oscillator, or if I go beyond this transistor here into the filter, things will start to look a little bit more like they should. But there's still a lot to go, in spite of the fact that we've covered quite a bit of this board. Of this board and all of the traces on this board, that's the lower level, I need the top level, we have covered this much. which means we're getting there, but you can see that we have done the creamy filling in between our two solid layers of cookie. We need to do the top and the bottom, and that will get us there. That will get us closer and closer to actual functionality out of this thing. I am tired. I have been working for 5 hours on this and nothing more. So I'm going to take my leave of you guys. I would like to stream later. I would like to be going later in the afternoon like this, but I do have a corgi puppy that I have to take care of. So I got to go take her for a walk, and in doing so, touch grass. I would suggest you guys do the same. That is not to say walk my dog and touch my grass. Touch your own grass. You guys have access to it. Yeah, Willa needs her walkies. It's actually, I love all the discourse around gender politics and pronouns and stuff, and all of these idiots that are like fighting against sort of any of the new standard norms of accepting people, because those same people throw a fucking fit if you misgender their dog. And I run into it all the time, because people are like, oh, he's such a good boy. And I'm like, oh, she's a good girl. And they're like, oh my God, I'm so sorry that I, it's like, dude, like, what the fuck? Like, the same people that, oh man, it's hilarious. Yeah, no, I don't care, and the dog doesn't care either. But yeah, she is a girl, as far as I know. And she is the cutest. She's very, very cute. Creating content is limited. You definitely exceeded that today. I appreciate you guys appreciating the stuff that I'm doing, and I know I'm like an exposed nerve in the way that I'm talking about the content that I'm doing, because there's two elements to it. One is that there's a big drop off in the number of viewers, especially for a Friday. I think the last low user stream I had, it was just after 4th of July, so it's probably some other factor. But I do know that this stuff does not drive users as much. So I'm like a wounded puppy. Like, just don't mess with me, don't hurt me. So when I see lower users, it affects you. But we'll get people back. We'll do some other stuff that's a different form of engineering. I want to do this while I'm still like, I've got all this momentum going into it. I thought this was going to be a much shorter thing, but this is a big project. This is a big synthesizer. It does a lot of stuff. I would well and fully support buying one for $350. I think they're actually at $600, but it's really interesting to watch. I'm glad you guys enjoy that. Yeah, and you can find anybody to watch anything on Twitch, but you guys decided to watch me, and that's really important. The end card is totally out of sorts because OctoJ died. He's still alive. He's just busy. Oh, that doesn't work in YouTube. I went in the wrong window. Oh man, I fully transitioned into a boomer. Still working on my own stuff as it is. Hell yeah. Even when I leave your channel to watch some very specific content as prime time, it's Friday comes around at 4 o'clock California time. Yeah. All right, so there's the end card. I don't know about rating anybody, but I would check out Flatulent Gonad if you guys get a chance. Let's just look. A lot of people have been coming back to streaming, sort of that pandemic hangover from having a lot of users. And then people have taken like breaks, and then they come back. So I'm starting to see a lot of various people doing some cool stuff. I don't even know why. Wait, why am I following this person? Weird. Never mind. I can't find anybody to raid. You guys know where to go. I'll be back in 27 years, 4 hours, 42 minutes. I'll be back on Tuesday. And you guys can check the Discord. There's a link for the Discord over there. I may get the next stream stuff. I might undo all that. Or I could just set, like, maybe I can get in the habit of setting that. I'll have to figure that out. Anyway, you guys do what you need to do, and I will be back on Tuesday. I might make some personal progress in reverse engineering this thing, and then we can continue on from there. Or I can drop this crap and work on something else. We'll see what happens. But I'll catch you guys then. Until then, catch me on Discord. Bye.